understand that I don't wanna play your game.
The Earth is very flat.
What's going on, everybody? It is Wednesday, September 8th, 2021. This is Brandon, host of Brandon's Show. See, we got plenty of people in the chat. What's going on? Good to be with you tonight. Ian Adams, Gadget Inspector, PJ Cruikshank, Cleary, Page 42, Mike Dornan, David Wrestler. Looks like you were also artillery in the Army. One of those two, huh? Howitzers. That's cool. Cleary, what's up, man? Let's see who else we got. Busy chat tonight. Good Servant. I think I say that almost every night. Shills vs. Shills, what's up? And Bill G, who according to this was first, but I have a feeling the chat got cut off because I restarted my computer. Good evening, PJ. What's up, man? Ian Adams, what's going on? All right. Good to be back with you tonight. Sorry about the cancellation yesterday. Got to do what I got to do, though. But we're here tonight. Usually we do Flat Earth Wednesday. But since we missed Monday and Tuesday, I figure we'll have an open panel and do that tomorrow night. So just kind of shifted over one day since, we haven't had a show for a couple days. Hope that makes sense. And then we'll get going. It's just over at Jose's listening in on Ranty, who is pretending that he's saving souls from Flat Earth. So that was kind of disheartening a little bit. But anyway, we'll get going. We got a bunch of people in Discord. We're gonna have a good show, and we'll see where it goes tonight.
Dave, you're talking about the 69 per 1.27 miles east to west, where it's constant, but along the latitude, it goes from 68.4 miles per degree all the way to 69.4 miles per degree from the North Pole. So, in a sense, you're correct where they're not. You're correct where they're not squares, but at the end of the day, it's still straight lines and angles.
You're still talking about the longitude and latitude lines. I'm not. I'm literally talking about the area shown on the map.
Yeah, that's what I'm looking at. I'm looking at the maps. So the maps themselves, east to west, will be a constant 69.127 degrees east to west. But as you go north from the equator, it starts at 68 miles per 1 degree. So it actually stretches out as you proceed north. So if you're going to map that out, that distortion out from that angle measurement on the ground, what is it going to show? It's going to show you that it actually gets higher at the equator to the North Pole. So it's like a bowl, right? So you're trying to map out a bowl, not a fucking curved Earth.
Oh, so it's a bowl Earth, not a ball Earth. Ah, nice.
No, it's just to think about how to contain. Think about how water's contained, right? How water's contained, you'd have to have higher. You'd have to have higher edges all around it. So.
Hold on.
There's no hollow Earth.
There's no hollow. Okay.
There's no hollow Earth, buddy. It's all good. I'm just talking about how the landmass would be, because if you increase your elevation, your angle measurement will change, right? So if you try to map that out, I would assume that there'd be that's the form of distortion between the degree of the sky and the ground, because you have no way to go to the sky to see exactly where that is, and all you can do is measure using the law of sines. Is measure the distance between 2 points on the surface of the Earth and those two angles to get your distance, and then figure out the differential change between the 2 points. And if you take an assumption of a 360-degree circle and times it by that, you can get an apparent circumference size. So if you want to use that, that's fine. But at the end of the day, it's using straight lines and angles from point to point to get that information. So what they've decided to do is to get out of that, they needed to, create a triangle, creating a 270 degree, right? So, or more than 180, and that's what they had to do to get out of that train of thought. So, you want to look at what we used to navigate with. There's no need to think of a ball, dude.
What's going on, everybody? How's it going? It is live on YouTube. How you guys doing?
What's going on, Brandon?
Hoorah.
Fine.
How's
Bunch
Brandon
of people
today?
in here. I'll let you respond to what.
Hey, what's
I
up,
was saying
Brandon?
Here in a minute. Kool-Aid. What's up, Rob? Data. What's going on? Let me call out everybody
All
that's
good.
in here. We got Percentage, Ali B, Autodidactic, Billy Sanchez, Boofus, Chikey, Conrad, Conspiracy Santa, C Stel, Drink of Kool-Aid, Enigma, Face One, Farming Ganja, Effie Walker, FED, First Incubus, Geo, I Fart Helium Breath. Oh, all right. J711, Jeremy, Science Proves Things, Con with George, Moon Gazing, Napsonaut, 501, Rob on the Level Keen, Roger MC, Sin, Seek and Find, Silent Zero, The Real Bob Dole, The Rig, and myself. What's new? Anything?
Hey, what
Anything
up?
going on?
Just
Not
talking
much.
about the
So-
nautical charts. If you look at them, there should be a constant measurement of 68.127 degrees east to west. And when you go from the equator to the North Pole, it appears to flatten out degrees as you measure. But I was just saying, how would we have done that back in the day? We would we would have used the law of sines to calculate, I believe, some of that information as we tried to map out where we were from the equator to the North Pole. Because I think that would be the easiest to do first. And I believe Captain Cook, that was how they used the latitude lines first to devise a lot of that map information. But if you do look, the maps do have an irregulated, a regular square for the nautical charts, which would be indicative of that 1 degree measurement every 69.12 miles changing north to south. So
It's not that much of a change, is it? It's like very
no, but
slight,
it's a change nonetheless, and it would kind of substantiate that it's right. It's increasing in height, according to their own theory that there's a bulge at the equator. We know that if it would just increase in elevation period, the angle to that measurement of Polaris would change, or whatever method. But yeah, to Polaris would change, right?
Yeah. I'm curious when they started talking about the bulge. I've never looked into that at all to know what the genesis of that was. I don't remember hearing about a bulge when I was a kid.
They didn't start looking at the bulge, so they looked at my pants.
Okay. So it had to do with what Jeremy was wearing. Gotcha. Another thing that it seems like it changed over the years. This might just be my misunderstanding when I was a kid. I seem to remember them saying that once you got above the Kármán line, that's when you started going weightless. And I don't remember this whole story about falling around the earth and whatnot, but I think that might just be my own misunderstanding. Does anybody else have any memory of them saying something like that?
Yeah, something
Well,
like for the
that
moon,
was
for
my
the moon
belief.
trip. Yeah,
That's how I
That
used to
was my
think of it
belief,
as a
you
kid.
started floating
3 times
when
the
you got
slingshot.
outside.
Once gravity didn't have a hold of you, you were weightless and floating.
Yeah,
That's what I was taught as a kid.
that's what.
You remember that too, Ali?
Yeah. Well, that was my belief. I used to think that if the Earth stopped spinning, we would all fly off as a kid. So
Huh.
I remember it differently. I remember them saying like it was like everything's falling towards Earth, but by the time it gets there, Earth had moved out of the way. So it's like an endless, bottomless pit of just constant falling.
Yeah, everything's falling. Everything in space is always falling.
Okay. You remember
And I
them
tried to
saying that?
wrap-
Okay.
Yeah, I tried to wrap my mind around that and then figure out, well, what exactly does that look like? That it just happens to move out of the way at the same time it's pulling it along with it and moving in the same direction.
Yeah.
Right.
It's
I'm like, wait
crazy.
a minute here. This doesn't add up, right? You've got like all these competing vectors at the same time, and nothing. And it just, at some point, it just falls out of the sky. It just their satellite crashed today.
And you're at the
Right.
same point in the center of gravity too, and you can't like up and down is different than left and right. That's what's not. I'm not getting that part.
They kind of do that today too when they talk about look at the hair on the ISS. They tell the kids to like swallow their toothpaste, look at the hair. They kind of pretend like they're floating. They give this false impression of the model because they want to not really make a positive claim. They just want to say, "Hey, look at me on, hey mom, I'm on TV," like that one guy did for his weird tour of the ISS.
Right, where he dropped the screw. Yeah.
Yeah, and then like the Velcro went right through his head when he like turned the corner.
I don't remember that part.
Well, he was like, "Look, mom, no hands," and then like he lifted his hands up and like kind of like floated there, and then turned his head in the Velcro. Here, I'll see if I got it.
Yeah. I think it was just my misunderstanding. D. Ross says another misunderstanding. Space doesn't and never has equaled weightlessness. Yeah, I don't know. I'll take
How
your
could
word
you
for it, D.
differentiate-
Ross. But
Yeah, but
How
why
could you
would
differentiate-
why would hair go up? Why would your hair go up in space?
Well, where's the different resistance on a sphere's outside edge? Isn't it supposed to be equal on the sphere?
Unless you float.
yeah, right. So you're going around. I get what you're saying, D-Mac. So you're going around 17,000 miles an hour, right? And you're perpetually falling towards the Earth, but missing it. So you're going around in a circle. So I guess what they're saying is it's just the what is it called? The centrifugal force that makes you weightless. Just like a vomit
But
comet,
doesn't it-
it's just like a
Free fall.
continual
You're
vomit
free falling.
comet.
Yeah,
Don't
and
they?
yeah, kind of like
don't
that.
they-
And what's also funny, there's one quick thing. What's also funny too is that from your point of view, the Earth is not moving, but it has to move out of the way. But it's not moving. But it moved out of the way, but it's not moving.
It
Like
leaves
this
the bullet.
endless. Oh, go ahead. Sorry.
It leaves the bullet and comes back. Remember that one?
No, what's that?
The Coriolis. The Earth and the bullet are supposed to separate and then meet each other again. You've never heard that?
No, I don't think I've ever heard that one.
Damn. Yes, they told me. It was like the bullet leaves the Earth's
Don't-
surface, and then the surface meets the bullet back again through its rotation and its spin and its gravity and its wobble.
What the fuck? Okay.
Don't they get on here and tell us that that's what weight is? It's a measure of the force of gravity's effect on an object.
Yeah.
So that would mean that if there is no gravity, it would literally have to mean there is no weight because there's no effect of the force on the object because there's no gravity.
No resistance,
which
and they
would
tell
mean
you
there's no
gravity is resistance, right?
Well,
And
it would
that's why it's
still
called
they'll still
weightlessness.
say it has inertia, right? Because of mass. I've gotten into that with George before. But I don't know. Sometimes I just sit back and think about this, what this story is that they tell us about what the Earth is and what's going on, and it just sounds fucking crazy. I don't know if anybody else does that. But.
Yeah, it's a whopper, all right.
Yeah.
Right from the very beginning. Nixon's like, "Hey, I'm gonna go to the moon for peace, everybody." Great, Nixon. What are you gonna do after you did that? Carpet bomb Cambodia because you're mad at Vietnam? Like, you just told me you went to the moon for world peace. Why are you carpeting bombing Cambodia with more explosives than were used by all countries in World War II because there's something going on with you in Vietnam?
Don't point out the Cold War getting us there.
And then never again, right?
For peace. The Cold War got us there for peace, the war.
Oh, that's funny. Yeah,
Yeah,
and it
their
just
story-
happened to be the last year of the 10 years they said they were going to do it in, right? That's fucking convenient.
Do you know what's funny? And by chance, what are the odds that the base of the pyramid, or one of the bases of the pyramid, matched the longitude and latitude line of these nautical maps? What are the odds of that?
It's good odds because they were using the pyramid to try to see if the Earth was round or flat. Same with total, all kind of shit. It's what they used. That's what they were trying to do. A lot of these groups secretly were trying to figure this shit out to the extent they could.
Well,
What do you mean by that?
there's
How
an
are they
interest-
using the pyramid for that, Demont? I've never heard anything like that before.
Fill,
So-
size, radiant, just the way a pyramid acts on a level surface as compared to a round surface. How you would see something. They were trying to figure out what they could do to see whether they're on a round or a flat. You know what I mean? Like optically, like measurements, levels, all kinds of shit. They did all kinds of stuff. They built all
So
kinds
they're claiming a quarter square, which is like 3,000 and something. Anyway, the point is they literally take the square of the pyramid and they break it down, and it looks like it's related to the 1 minute or 1 degree of 68.127. So it looks like both. It's not, the pyramid is not a perfect square either. It actually is elongated a square, so it's more of a rectangle. What's that?
I was gonna say, it does seem weird to, like, sometimes they're like, where's the top of the pyramid? Well, maybe that was used for like some type of thing to like see like plumb bob type shit they had working it, and like they had maybe a thing balanced on top, like a balance, you know, like the scales of justice, like a balance, and they had a plumb bob on one end and a plumb bob on the other, and the plumb bob didn't pull towards, it didn't make a V design. You know what I mean? So they probably had different, and then the totem pole, yeah, different observations.
Hey, Brandon.
Yeah. Hey, what's up, Silent?
How you doing? Send you a message with a timestamp. I don't know if you want to see that. It's one more of the crazy stories that they can tell.
Oh yeah, I like crazy stories. Let's see here. Is this daily dose of internet? This thing?
Yeah, but click on the link. Okay, it's timestamp. And don't.
Okay.
The pyramids would have to do with orientation too, and like ley lines. So you mark a position, so you have that marked, like a definite marking. Like you can't like mistake it for anywhere else.
Well, I'm just saying, what are the odds that 150-year-old nautical charts that are still being used to this day apparently have the same dimensions as these pyramids, right? What are the odds? You say that they're very good, and I say, well, how would Captain Cook have gotten the measurement of the pyramid? Were they doing that back then? Did they already have that information? Like, what point did they have? So they already had this sort of predestined for us to find, right?
Like what you're asking
By
is
the
what
time you
does
have
that really mean?
you have a culture that is far enough advanced to sail out of sight of land and reliably arrive at their destination, they no longer believe the earth is flat.
I'll just say the pyramid is like a scale itself. It's also like a sundial. It also works on a flat base. So there you go.
Really? So, Kool-Aid, the Mayans
Yes.
didn't sail?
I believe the Mayans were coastally locked. I would have to double check on that one, but I believe just out of memory, I believe they were coastally locked.
So you're saying that no one who sailed long distances back in antiquity thought that the Earth was a flat plane. They all thought it was a ball.
Yep.
How the fuck would you even know that?
The history of the astrolabe.
You haven't studied
before
any
we get in that,
cosmology.
Hey, just out of curiosity, if you know the history of the astrolabe, who was the first one to invent it?
Those were port towns, dude, in Mexico. So I don't know how this guy's talking about. He better not be a Glober.
Who was
I am
that?
a
That was
but by the way,
The guy that
just
said
before
the
we get too
Mayans.
far away from it, Sin, are you still here?
huh?
Sin gave me a quote for the 600 nautical miles treated as flat, and he gave me the Bowditch. I just looked up the Bowditch. The fifth section, it deals entirely with dealing the spherical triangle problem. So I really doubt he was saying anything about flat, as he wrote an entire chapter in his book about how to solve that problem.
Spherical
Yo,
triangle.
what's that about a spherical triangle?
The spherical triangle problem.
Well, let's not get into it. Let's go back to the silent zero thing.
I'd rather you elaborate on the spherical triangle problem.
No, we'll get back to that. So what's this silent zero? This dog wakes up to a creepy bear is the name of the video. I got it up on the timestamp. What are they showing here? The hell? What's going on here? Still there, silent zero?
What's up?
Your video.
Oh,
What is this thing?
Oh, listen to what the guy says. If
Oh, it won't come through the Discord, but let me play it.
yeah, listen, you can listen to it.
The Milky Way galaxy isn't entirely flat like we originally thought. It's actually wavy. Okay. Oh boy.
I mean, at this point, these people, they just like I guess they wanna know how far they can push it, right? Into madness.
Just basically to sum it up for everybody, when you're looking into Einstein's special theory of relativity and then general relativity, they call special relativity, but it requires just Euclidean geometry. When you use general relativity, which is general, right? It's basically a quantification of special relativity, which is everything's moving at constant, where general relativity is everything has velocity changes or changes of momentum. It's ass backwards when you call something special relativity that's less complicated than something that's called general relativity that's more complicated. So it's just kind of in the language anyway.
They invert all the information and all the shit. That's why people are confused and like, well, wait a minute, why is it like that? Because they invert the information and lie to you about half the shit. What they're telling you is true to a certain extent, but just think about it backwards and you'll probably come out better.
That does seem to work a lot. I will agree with you there. Huh. Yeah, a wavy Milky Way galaxy, huh? Is this just, what are they just rotating it? This thing is not said to wave like this, right?
A wavy Milky Way.
I'm sharing it on my screen. Does
Well,
anybody
it's always
know?
something, ain't it, baby?
Is it supposed to be actually waving like that?
That's okay. I'm just trying to go home.
It's called special relativity because it's relativity in special conditions, including moving really fast, right? It's called general relativity because it's in the general context. That's why it's not difficult.
One is at constant velocity calculated and using Euclidean. The other one is not at a constant velocity using Euclidean. That's the major difference.
Special relativity, it has nothing to do with constant or not constant. It's at specifics. It's at
fundamental
really
break co-show.
General
fundamental difference.
General relativity.
The fundamental difference is exact. The fundamental difference is one is constant, one is changing. That's one of the. And besides, one's flat, one's curved. Yeah, but at the end of the day, it comes down to one's being calculated a constant and the other is not.
Huh. Okay. Yeah. So we live in a big wavy cloud. Huh? What's the thing at the center of the cloud? That's the great attractor. Is that right?
No, it's called the Milky Way because of what it looks like in the sky is the center of the Milky Way galaxy. But every star you see in the sky is in the Milky Way galaxy. Okay, the cloudy part is just what it looks like. That's why it's called that. It looks like that in the sky. That's just the center. That's just the center looks like that because it's a collection of a lot of stars concentrated. It really does look kind of milky. But all the stars in the galaxy and in the sky are in the Milky Way.
You think we live in this thing? We're floating around in this thing, Kosha?
I wouldn't say floating, but yeah, we're in the Milky Way.
Of course you wouldn't say floating. What's it called when you're not attached to anything solid and you're in a vacuum and you're
detached? I don't know.
Suspended.
Not attached to something, detached.
It's called falling.
Detached. Oh, okay. So you think we're detached in this?
No, I think that we're orbiting the center of the Milky Way galaxy, just like all the other
fuck's
stars.
sake.
Floating typically denotes this idea of like there's buoyancy and like you're in a medium, all that kind of stuff.
Falling with style.
So there'd be a resistance then, RC?
What are you talking about? Resistance.
Something floating?
It's a beautiful thing.
Let's look up the definition of the word floating. Yeah, buoyant or suspended in water or air. So I'll give
There
you
you
that. Not settled in a definite place, fluctuating or variable. You got to give me that one.
Mm,
All right.
Not really.
50
That's usually,
50?
no, not really, because a float is typically in computer science what we talk about in terms of like numbers are not being definite.
Oh, okay. All right.
Yeah. So I'm just saying floating typically denotes that you're in a medium, just like this definition says right here. And so yeah. We're not
All right. I'll give you that. I guess if you guys got to
I
be pedantic about the word floating, that's fair.
mean, we weren't being pedantic about the word floating. You
Yeah, that's
said
fair.
you literally asked us, would you say we're floating? And we said, well, not really, no.
Yeah. I would say we're floating. If you think we're inside that thing, held up by nothing, to me that's floating. But I guess
We're
that's
not
just the
held.
layman's
What do you
term.
mean? It's held up by gravity, right,
I'll,
Mikey?
Held
point
up
out
would
that
imply
it's
would imply
actually-
that. Oh my gosh, held up would
it's
imply
literally
that there's.
impossible.
Why do you just talk every time I'm saying? Held up
What?
would imply that there is a down versus an up in this particular instance, and there's not.
That's because there is, you numpty.
Explain more.
There's an up, there's a down, there's a left, there's a right, there's a
On-
zig,
on-
there's a zag. There's an over, there's an under, there's a before, there's a behind.
Those are up and down are relative directions here on Earth based on.
That's right. That's where we live. We
You're
don't live
in a-
out in La La Land where you have to redefine all of reality.
No, we live
scared
in
of?
this thing, Travis. We live in this cloud with a
Yeah.
lot of stars in it.
I'll point out that it's literally impossible to determine your location from inside of a thing without having knowledge of what's outside of that thing. You can't do it. So anyone who says that we live inside the Milky Way galaxy, but then hasn't been outside of it and then tells you that they can determine where the center of it is, they're mentally retarded or they're lying.
So you can't tell that you're in a city, and you can't tell where you're at in a city if you've never been outside the city. No, that doesn't make any sense.
No. That's not what I said. That's not what I
Yeah,
said.
you
Without
just said
having
you
knowledge
can't
of what's
determine-
outside. Without
you
having
can't-
knowledge of what's outside
you
of
just
it. You
said
don't
you
have
can't
knowledge of what's outside the
determine-
Milky Way.
You just said you can't determine what your location if you are inside something, that you have to go outside of something to determine the location.
No, that's not here. I'll say it again, and I'll try and do it a little bit slower. Try and listen this time. You cannot know where you
listened the
are
first time
from
and you
inside of a
made no
place,
sense.
inside of a thing, without knowledge of what's outside of that thing. So anyone who is claiming to know where the center of the galaxy is that we allegedly live inside of, who hasn't been outside of it, is a liar or retarded. Because they don't have knowledge of the outside.
Wow.
So do you
That's
understand now? It's
very-
not that you have to be outside the city.
That's
It's that you have
very
to have
interesting.
knowledge of what's
All right.
outside the city.
With that
Why
same
can't I
logic,
look out and say that everything is a certain
No.
distance from me,
with
and
that
then
same
by
logic,
that token determine where the middle is?
you don't know the dimensions of the flat Earth. It can be flat then, based off your logic.
No, I
Yeah,
said
the
nothing
entire
about a state.
he's right, Bob. The entire construct could not be flat.
Characteristic.
You've never seen the entirety of the flat Earth, so how would you know flat if you don't know the whole?
Yeah, exactly. For sure. Absolutely. I have no problem
All right.
saying that. I've never seen the
Why-
whole thing, and there's all kinds of things it could do near the edges, or if there even is an edge, maybe there's no edge. I have no knowledge of that, and I never claim to have any knowledge of that.
All right,
So
I got
there's
a
no
question for
argument
you.
there.
If
So
you
now
were
that you've
living,
agreed
let's
with my logic, agree then that you can't know that without having information about what's outside, right?
let me ask this question. If just as a hypothetical, if I lived on a bicycle wheel, like sort of as an analog to a galaxy, and I was sitting somewhere near the or on the outside periphery, and I looked it out and I saw that a method of using parallax and whatever else to determine distances. I can find out the distances to the wheel on the other side. I can then therefore determine where the center is just by determining the shape
Here's the
from my one
problem.
location.
Here's the problem. You already decided it's a wheel. You decided you were on the outside, and you decided the distances. You had knowledge outside
No.
that thing.
I looked at it and I said, okay, I'm looking here. I see all this. Now take it to Earth. I'm looking out. I see that there's stars in a local cluster around us in our galaxy. And I look across, and then all the other stars are way, way far away, except for all the ones that I can see that are in our local cluster in the Milky Way. So now I take distances to all of those, and I can say, okay, well, it's this far across, and I can now determine all the things I need to determine where the center is.
But what about the stuff that's outside of that? That's still part of the galaxy.
That's not part of the galaxy. That's part of the universe.
See, you don't know that. You haven't been there. You can't determine that. You can guess that if you want to. That's fine. You can have that guess, but you have no way to actually determine what is and is not inside our alleged galaxy.
Okay.
I determined the distance to all the things in the Milky Way.
Can I just give you a definition right from NASA of what they say out of their own mouths, right? Calculation of the radius of the universe. Scientists, and this is just how it starts off. This is right from Harvard, NASA. Scientists speculate. That's the first two words.
Right. This is but we're talking about universe, not galaxy. He was talking about galaxy.
It doesn't matter. Okay, so we can do
I'm
galaxy
talking about
then?
literally anywhere. You cannot know where you are without having knowledge of the outside of where you are.
Right. We can't determine the shape of the universe.
But hold on. There is a calculation in dark energy that has the radius of the universe in it.
Really?
I believe so. I believe it's got the Hubble constant. It's got the. Let me just read it off. Give me 1 second here.
So, what part of this space egg do we live in? Are we on the outside, or are we at this yellow arrow, or what?
Well, I mean, you can look at the Andromeda galaxy and see a very similar shape. We can literally look at other galaxies, look at their shapes, and see how they're behaving.
Ah. So we see another space egg in the sky. Therefore, we must be in a space egg.
I mean, I've looked at Andromeda through a telescope. Hundreds of thousands of other people have looked at this thing. You can see it for yourself. I mean, it's not a.
No one said it wasn't there. I never said it wasn't there. There's something up there. We see the stars. We see these things. You've given names to all these in your in your religion. I understand that you got this all mapped out.
Right, but it has.
So I apologize. It's the curvature of the universe is what's calculated. Okay, so they're calculating the curvature of the universe in these formulas. So if they speculate the calculation of the galaxies, or in this case the universe, the radius of the universe, then they must have to speculate as well what the what this formula is implying, right? You have to take guesses, in other words.
Yeah, and as you get further and further away from Earth, the numbers become less and less accurate. I mean, that's an understood thing. If I'm trying to guesstimate how far away that mountain is in the distance, only using my eyeballs, I'm going to be less accurate than measuring to my front lawn and to the school in my town, and stuff like that. It's
my apologies.
We have
Yeah, they
limited
do.
ability to actually look at things across the universe.
So my apologies. Yeah, in the formula they do calculate the radius of the universe. So they actually do. So I can show you from two sections here. One is the actual dark matter concept, and derived from that dark matter, you get a calculation, right? Which is the cosmological constant, the speed of light, the Hubble constant, the gravitational constant, the curvature of the universe, mass density of the universe, and the radius of the universe. So if I can tell you that that's the formula that they're using to match the observations that they see with their eyes, I can go and show you right from their site that they have to speculate the radius of the universe.
Right.
So it's just
But were you saying, the other guy who was talking to me a second ago, were we talking about, because you specified the galaxy, and I think that it's quite easy to determine the size of our galaxy and where the center is and all that sort of stuff. Do you disagree with that still?
Like I said, it's just speculation, right? And I just backed it up. So there's
Not
no
for the
point
galaxy.
to
You did the universe.
everything. It's everything.
Galaxy. So are we talking about the galaxy or are we talking about the universe? If you're talking
anything
about
that
the
anything
galaxy
that
we can determine.
anything that man is looking at outside of his own physical reality is required to have a philosophy and to interpret the information. I can just show you clearly the information that's being interpreted is speculated upon in their own literature, and then I can actually break down. And hold on, and I can actually break down. Hold on, I can actually break down each calculation, albeit that I don't use these calculations and retain the information on the results of them when used. I can just compartmentalize each concept of the equation, how it's put together, and then show you literature that shows you how they're deriving each calculation, and it's usually from speculation. That's all I'm saying.
All right, go ahead and do one. Hey, hold up, Data. I actually want to test you on this one. Data, just do one of them. I want you to actually.
I would have to take some time, brother, to be honest. I'm going on the well, yeah, because it's not something that I'm going to sit down there and break down. If I took some time, yeah, of course.
Well,
but what I'm doing is I'm listen. Listen.
Have you never actually broken them down?
Yeah, so if I'm going to study the material, I'm going to have to understand how they put them. Yeah, as far as putting them to application, what I'm doing is I'm observing, reporting on exactly what your science is saying. You don't like what your own science is saying. Okay. Listen, bud. Listen. All smiles, no serious. All smiles, no seriousness, dude. All I'm doing is observing, reporting. You might be offended by that. So, for instance, if I tell you that the Hubble constant, information doesn't match the Planck satellite information, that's not me saying that. I'm just regurgitating your own science. If I tell you that if I read off the formula for dark matter to understand the concept of the expansion rate of the universe, although I don't use these calculations or have the equipment to study these observations, what I do is I, on a surface level, have to understand what they're trying to describe mathematically, okay? So through their own description mathematically, they're telling me that they have to speculate, and they're using these calculations to derive.
Hold up. I'm asking you a very simple question. Have you ever broken down... Hey, stop. Have you ever broken down any of these equations that are used in astronomy? Ever.
Okay, so have I looked at how each of the constants were derived?
No.
Yes.
Have you broken down any of these equations?
Do I have any observations to apply this to that I've done myself?
Oh my gosh, why do you just keep asking a new question?
What do you mean by broken down, RC Meisty? Clarify what you mean by broken down.
Yeah, so I'm asking him, so he says that he can show all of the assumptions behind all of the equations. And I'm saying, just name one equation that you've broken down and showed an assumption for in astronomy.
You had to assume this.
Well, I don't think you understand my point here. I'm taking
Can you name one equation that you've analyzed?
Brandon,
yeah, I have a dark energy formula that where I show you where the issue is with their own. I'm just copy and pasting, dude, from your own science. The issue is, break
it down for me. Show me one of them.
Okay, so if you're looking at the data implication or the calculation for it,
show me the equation that you said you looked at.
Okay, so, well, I'm not going to share my screen right now to do that.
Just post it in the chat then.
Brandon.
Okay, one second.
Hey, Brandon, I give you a link for how they calculate the mass of the sun. This was from Bio yesterday. I don't know if you want to bring it up so that we can see all the assumptions.
That's a good idea.
That are on the formula.
Yeah, post it.
Yeah, it's on your messages. You wanted to post it in general?
No, that's fine if it's in
Flower Data, show me one equation that you have analyzed yourself.
Really, the mass of the sun, I would think, is relatively easy. All you need to know is the mass of the Earth and the radius that it's spinning at. And you kind of get the mass of the sun, don't you?
Well, let's not get off track here.
I'm sorry.
Says that he knows how to break down one of these equations. In fact, he said I've broken down all of them, is what he said.
You don't
But
forget.
I don't-
Impressive. I can't.
But I'll just say he was being hyperbolic there. So let's give him the benefit of the doubt. Flat Earth data break down just one
So
equation.
is that what you heard? So do you interpret break it down? So, well, can you tell me
Yeah.
what you mean by break it down? Do you mean
So
like
that's what you said. You said.
Did I say
You
that?
broke it down.
So
Yes.
what I said is I can show you it compartmentalized. Each equation,
Okay,
how
go
the
ahead. Go ahead. Show me one.
So what I'm saying is that I can copy and paste and show you where the formula is derived from.
Okay,
the constant.
show me that. Show me that.
How they're put. You want me to actually just go through like?
Yeah, I
copy
want
and paste,
show me
like-
any equation that you
You see,
have
Brandon?
shown where it's derived from.
They
Yeah,
give
so-
them this on school, right? And this is
Oh.
they learn this. And
No, we're not we.
that
We're
makes
not
it
we
real,
here.
right?
I'm asking Data. He's saying that
shut up,
he
Mikey.
has actually done this. So go ahead, Data. Go ahead.
You don't need to do that, Data. Don't.
Yeah,
don't-
nobody cares.
If he's looking down, if he's looking,
fake it.
Hey, Data,
Yeah, if
are
he's
you
looking
looking
for-
at Brandon's stream right now? That's what he's
Hold on.
asking from you. Look at that equation.
Oh, cool. This is the most simple one that they learn in 8th grade. Go ahead, Data. Break this down for us.
Well, it's right there. Assumption number 1, universal gravitational
ahead.
constant. Yeah.
Go
Number
ahead, Data.
2,
Break
assumption
this
number 2,
one
the
down.
mass of the sun. This is an assumption.
Go ahead, Data.
That's
Break
not
it
an
down. No. I want Data to break it down.
why-
Data, go
why-
ahead.
Assumption
would I
3,
do-
the radius of
Why
the
would I
Earth.
play your game, dude?
Assumption
Measured.
4, distance between the sun and the Earth. Holy shit, you guys. Man.
Measured.
No, go
All
ahead.
of those
Go
are
ahead, Data.
measured.
Break it down for us.
Measured
Yeah,
radar range.
Okay.
Yeah.
All right,
You
Meisty,
just
I
want me
mean,
to time-
what is the
you just
point
want
of
me
this?
to you want me to times your beg of the question, right? Your
Oh, okay.
gravitational
So
constant,
I
you
gotta
want
ask you a
time-
question, Brandon. Here's the point. Data, in particular, a couple of times has said, "I've broken down these things and I have shown all of the assumptions." Yet I'm showing everybody in this room that Data hasn't broken down or shown the assumption of bullshit. Okay, because he doesn't actually know what any of these equations mean. He couldn't take a
Yeah.
derivative. He said,
Again,
"He knows what
you
they're
have
derived
no
from." Hey,
argument.
I'm
You're
done.
just a straw
Hey,
man, dude.
hold up.
You're just weak.
Then
That's
then
okay.
you said,
Just
"I
weak.
know where they derive from." If you can
Yeah.
show me one derivative of any basic equation in calculus, I'll shut up.
Yeah, it's not like I go out of my way to practice an equation to show you, dude. If you want to sit step by step, what do you want to talk about? What?
Yeah,
Like what
show me the
specifically?
derivative of any equation that you have.
What? Like what in particular?
The ones that
Are
we've
you
been
asking
talking
me to do? Are you asking me to do Einstein's tensor equations? No, I can't do those. Are you
Okay, so
asking
which
me
one-
to?
show me
Are you
any one
asking
you
me
should do.
to?
Any
You
one you
asking
want.
me to apply? You're asking me to apply these calculations to what? What do I have access to? What
Yeah,
what
you
I've
said that
broken
you know the
down?
derivative of these
Why don't you? Yeah. So when you research
So
where they
show me
come
any
from, and
equation you know the derivative.
so when you
derivation.
research where they come from,
Yeah,
right,
show
from
me any of them.
Galileo's observations, right, there's always the implication that it's gravity, claiming the mechanism, right. The point is all these calculations came from observations. Now what I've broken down is these theoretical assumptions based on observations. This particular formula that you're talking about is an observed constant that you've created for your apparent downward vector gravity force, right? I'm talking about the radius of the universe in the dark energy calculation. Do I apply that calculation to my reality because I have equipment to do it? No. I'm saying
No.
when
I didn't even
let me
ask you to
finish.
do
Let me
that. I
finish.
didn't ask you to
Let me
do that.
finish. Let me finish. When I study and when I learn about these equations and how they're derived, they're usually derived from an assumption on
Okay,
something, on
show
some
me
ground.
Show me
So-
one that you've actually found out what it was derived from. Go ahead, show me one.
Derived from like an assumption.
No, in anything that you said that you said I've looked at equations. Show me one of them that you've looked at. This is not a
Well,
hard question.
Okay, what he did
Okay,
is he
so-
just poo-pooed the concepts at a base level, saying that that's an assumption, therefore it's not we can't use it, right? Is that correct?
No,
Dan?
what I'm
that's
saying
what
is
I'm
in your
trying to
own.
figure
I'm
out.
saying what I'm saying in
Well-
your own literature. When I go to learn about the dark energy calculation, I have no reason to apply this. But yet, when I learn about the Hubble constant, when I learn about all the other ones, there's one that says the radius of the universe. So then you find out how was the radius of the universe calculated because it's part of the calculation, right? I'm not saying I use these calculations and break them apart and look at observations of the telescope. No, I never claimed that.
I didn't
I'm
tell
saying
you
as
you
listen to me,
did.
as I learn about these calculations, I learn how they're derived, and it's based on
Okay.
a
Show
pure
me
assumption.
one. Show
So
me one
how
of them.
can you how
Show me one of them that you
You
say,
proved
"Oh,
your
I
point,
see where it was
Micey.
derived
Let's
from."
move on. We know the
Okay, so the
cosmic
point
distance
is
ladder is riddled with
the point
assumptions.
is
That's
that
just a
the
fact.
scientists speculate the universe is 10 to the 56 grams, right? This is a speculation that the scientists have, and it's after the Big
Okay.
Bang. So they
Okay.
speculate. So that is the a formulation for the radius of the universe. That's one. In the dark energy calculation, the Hubble constant doesn't match the Planck constant. That's also another measurement for
Well, of course, the
calculation.
Hubble
So they have to.
doesn't match the Planck constant. Why would
But
you
it's
think
part of the dark energy. It's part of the dark energy calculation. So you find out that all of these calculations are compartmentalized,
Which dark energy
and when they're layered together, they don't have the right prediction.
Okay.
Now,
Okay.
now,
About the
now, hold on.
observable universe, and it's an easy calculation just from the
So
CMB.
again, all I keep doing is repeating your own science against you, because even your own
You didn't
science admits
repeat
this.
anything. You just said, "I looked at this and it doesn't line up." You didn't actually present anything.
Okay, so here,
It's
if you want me
also
to
not
present,
referring to
if you
like
want me
the
to actually
definite
present you a
size of
scenario,
the
I just
universe.
told
It's
you a
just the
scenario.
observable universe.
I just told you a scenario between Planck satellites and the Hubble constant. Okay, that's an
Yeah,
issue.
everyone in cosmology knows that there's an
So
issue
that's
there.
it.
They're trying
So
to
what's the deal?
resolve that.
Yeah, what's the deal? Why don't you admit then? You RC can admit it. You can.
Oh yeah, I
Yeah,
can
I don't
admit
have
it.
any
There's
issue
nothing
admitting it.
with
There's
dark.
like
So
there's
again,
4 unit
so when I
discrepancy.
learn about your fucking model, moron, I come across this shit.
Well, no,
Just,
you
do you
were
see my point now?
When you learn about the model, you realize that there are people that are exploring things that we don't know about. That doesn't mean
Ding
that we don't
ding,
know
no
anything.
kidding. No kidding. So why do you come
no
across
problem.
like you know shit? Holy fuck, man.
I think
No,
that was the only
the
point that Data was
URC.
making.
No, my point is that I don't think he's actually even broken any of these equations down.
Yeah,
Again, I
okay,
look at
RC, you guys can work it off
simple as
offline. If you want to
wasted
give
like
Data a
15
math
minutes
test and
talking
he
about
wants to
this.
take it, you guys can figure that out later, okay?
Yeah,
Because
that's not
this is a
interesting at all.
very tired tactic that you guys use. Oh, do calculate this.
saying that you debunked something
use
and you
this
haven't?
equation right now, or you don't know what you're talking about. It's very
Right.
tired.
Well, he said that he could.
Can I just back
No, I did. No, I didn't. I never said I could. I said I can. When I break it down, you can the constants that people have put together over the years through observations are combined in this equation. So when I said break it down, that's what I'm suggesting.
Right. Surface level.
just-
I don't believe that.
He was
and I don't
perfectly
believe
correct.
that
It's not
because
surface.
that's,
It's not
speculation.
surface level. It's not surface level. I'm going in bias, buddy. I'm just observing, reporting, and when I do that, listen to you guys squawk like little fucking chickens with your head cut off.
Well,
I'm just
not,
observing and
basically,
reporting.
I have no idea. The things that I say is the galaxy we can determine from within the galaxy. That's no problem. Solar system we can
How
describe
would you go about
without
that,
ever
Noyak?
having left the solar system.
How would you determine the
Without
size of
ever
the
having left the
galaxy?
solar I don't know why you're talking. Without ever having left the solar system, I can measure the distance to all the objects in the solar system from the
Only
my
by
distance to the
assuming
sun, and
you
I
know.
can determine the distance to the diameter of the solar system. Now,
That's the
something you
whole
can do
point.
from inside.
The whole point is
Whether
the
or not
cosmic
it's in the
distance
solar
of the
system.
ladder is riddled with
Finish.
assumptions.
Let him finish and then just address his point.
Yeah, Jesus Christ, fucking rude people.
Well, you said you could determine the
they're
distance.
fucking
You could
rude
determine the
people.
size,
You're
the
still
diameter of the
talking.
galaxy.
You're just told to shut up, and you're still speaking.
All right, just go on. Finish what you're saying.
Man, I didn't say shut up, man.
Theoretically, I can, from within a system, measure the extents of that system. If I can measure the most distant objects in that system, I can now determine where the center of it is. I don't see why that's inherently a flaw.
All right.
Because you have to make a mass number of assumptions to climb the cosmic distance ladder, right? They first determine the distance to the moon, then they determine the distance to the sun, and they use assumptions to do that. Then they use assumptions to say how far stars are away, right? By judging by their brightness so that they can kind of guess the size. And they don't have any actual firm information about any of that. It's riddled with assumptions.
I agree. There's an error bar in it, and I don't know what that error bar is, but like with the sun, no, that's been measured. That it was assumed there was assumptions, like the assumption of the size of Venus and stuff like that, but that actually appears to have borne out. And because we've
can I
taken the
stop you,
measurements
please?
now by radar, the distance to the moon has been checked through, about 6 different ways, and they all align with each other.
Can you show me one of them, please? As Micey just did
we've been there.
to Flat data.
Okay, we'll take
Let's
that one
request
away.
you give us
You can
one.
do it via parallax. You can do it via radar. You can do it via laser.
You're just saying words. You're not demonstrating anything.
You want me to
Hey,
what?
this is
Get my laser pen out and measure it?
Demonstrate.
So you want me
Yeah.
to show you an EME moon bounce, which you've already seen?
We want you to demonstrate.
You want me to demonstrate?
You
actually have
guys want us to act like
before.
fucking
You have seen
children.
moon bounces, correct?
Yeah. Yeah.
So we've got the moon bounce. You've seen the laser bounce, right?
What laser bounce?
You've seen the laser bounce, or haven't you seen the laser
Show me the
bounce?
laser bounce.
All right,
everybody
guys,
shut
come
up.
on. This is
Show me the laser
devolving.
bounce.
We just criticized these guys for trying to give data a math test.
Yeah, and then so we can't hold them to the same standards that they were trying to hold data. I could have shown Silent Zero tried to help
all I
data
can do is
out,
show you the
tell
papers
where
and
they were making all the assumptions, and then you want to cut me off.
They know that they're making assumptions. If they're going to sit here and say that they're not making assumptions and they know this all 100%, then they're out of their fucking minds.
100%. Nobody says 100%. It's to a high confidence.
The universal gravitational constant is an assumption.
The speed
Here,
of
I'll
light
give
is
you
an
one
assumption.
assumption: the mass of the Earth.
That's a claim of knowledge
Listen, just
of
real
the whole
quick, guys.
universe, buddy. That's a claim of knowledge of the whole universe.
Right, but listen.
There's no way we can know that.
Yeah, but listen.
So you gotta assume it.
Hold on, just real quick. This is another.
You're assuming that all the bodies are behaving the same way in all the universe.
Okay, listen, real quick. This is another demonstration of wizardry when they define an assumption as a fact that they know.
It's just like a religion, right?
It's not an assumption that we.
Do we ever claim that it's an
It's
exact
like
number?
I assume that God and the saints and everything exists. I mean, it's an assumption.
The speed of light.
Based on faith.
The speed of light seems to be 186,000 miles per second. That is a very good, well-vetted, tested assumption that is so far borne out in everything we've done.
Okay,
Where
can I go to get that?
Turn out that there's a time
Where can I
dilation.
go to get that information?
Does it behave the same way in the entire universe? Or are you just gonna assume that it does?
So far, it's borne out.
Yeah, so you're gonna, based on what you know, you're gonna assume that that's what is happening in the entire of the universe, right?
We have evidence for that.
Say the entire universe from
And
the
the
moon.
entire of the universe. What evidence do you have for the entire of the
Because we
universe?
can see things like explosions of distant stars, and we can measure the speed of light from the distance it takes. Can I just give you an answer?
There goes
ask
the
the question.
show.
Yeah, shut up, Travis. Stop disrupting things. I know you want to speak and mute everybody. So you asked a question about how we know the speed of light is a constant across the universe. Well, we know from explosions and things of supernova and the nebula.
Yeah, I wouldn't blame everybody for leaving right now with this kind of
nearly there. And we know from the distance we've actually measured we can measure the distance of the nebula around a star, and we can see when it's illuminated, and we can time that, and so we can actually establish the speed of light in distant galaxies. So
That's
we
nice.
know that we know there are places in the rest of the universe. We know there are places in distant parts of the universe which have the same speed of light.
What does the universe expand into, Rumpus?
Well, it makes its own space.
What?
It makes its own
He's
space.
not going to give us any proof. He's just going to give the same story. Like, he can't
Hold on a
give us
minute.
any proof.
What do you mean it makes its own space?
It makes its own space.
What do you mean it makes its own space?
It's expanding.
It's just like the Silver Surfer.
What is it expanding into?
It doesn't
making a
expand into
space.
anything.
Hold on,
It
guys.
doesn't expand into anything.
Hold on, guys. What is this expanding
He loves
into?
taking you off in the weeds.
It's
You
not
can hear the
expanding into
smile.
anything. It's creating space as it expands.
You are a
Rumpus,
fucking
why are you
religious
outside of the solar
nutcase,
system?
Rumpus. No offense, but you know you're in a religion, right?
No, do you know that all this is based on evidence?
You know
and
you're in a
theory?
religion. You are in a religion. I'm just here to tell you. I'm not
Well,
trying
I'm
to be
here to tell you you're
offensive to
talking
you.
bollocks,
You
and
are in
you're
a
ignoring
religion, and you are
scientific
akin to the
evidence. You're a
people who
science
used to
denier.
try to
You're
calculate
denying
the number
science.
of
scientific
angels that would fit on the head of a
evidence.
pin.
Yeah,
You're
your
not
kind of science,
capable
we
of
do deny.
understanding
Yeah.
argument and evidence. You're a
Oh, now I'm not
science
capable of understanding. Yes, of
You're not
course.
capable of understanding the theory
Brennan.
or the experimental evidence that
Of
supports what I
course
said.
I'm
You're
not capable of understanding. I don't
something we
believe
can
what you
just make
believe.
up in our
So it
heads.
Yeah, but
must
I'm
be a
backed up
short
by
hold
evidence.
on. A shortfall in my capability,
very
right?
intelligent people who've thought this through and have derived from evidence that we can observe that this is true.
They're intelligent people who run Scientology too.
Excuse
What
me,
assumptions
Rumpus,
does
They're not
I'd like
flat
to
Earth
just
make?
try to bring this thing back. I mean, you're
Yeah,
going
they
into
got
such
made a lot of money.
theoretical shit that's so far away from Earth. The speed of light is tested definitely like down at ground level, yes.
And then
It's
you're gonna
tested
assume that it behaves like that in the entire of the universe, right?
So hold on. I'm not getting out to the universe because we haven't finished working our way out from where we are. We take ladder steps out into the universe. So as far as measuring the moon, Mercury, the sun, Venus, Mars, those have all been done via radar. And we know the speed of light has so far borne out to be 186,000 miles per hour locally. Now, I don't know whether somewhere, somehow in the universe, time dilation, weird, bogus gravity effects could affect that. But locally, it has borne out. And it bears out with checksums that you can do with parallax. So you can say, look, I see the moon. Parallax tells me it's this far. The radar tells me it's this far. Laser tells me it's this far. And also calculations and predictions tell us it would be this far if it had this mass. So all these things
let me
tie
get this
together
straight.
into one answer, which says if they were coming up with different answers with each one of these things, I would say it'd be questionable. But it's not terribly questionable, so it's a reasonable assumption that all these things are uniform.
That you can't confirm. Thank you.
Okay,
Dr. Seuss.
I like that one.
Thank you, Dr. Seuss.
Okay,
Yeah, I understand
I'm
what
out.
you're saying, Moyak. I'd be curious if we dug into all those methodologies, what they would all have in common. But
They
we'll have to
really
save that for
don't.
another day.
You got to go all the way back to the primary claim. You have to go all the way back because the speed of light is based upon a previous claim that needs to be addressed.
But it's checked out. It checks out via parallax.
Okay, but
so it's
listen,
sort of a nice
again,
fact
this is
check
what
on
I've
it.
said. This is what I've said from the beginning. Okay, let's just go with Eratosthenes. Eratosthenes, before he stuck his sticks in the ground and looked down a well, already assumed the Earth was a sphere. So whenever he got his measurements, whenever he got his measurements, all he had to do was put it into a spherical program. Everything after that, I'm just going to fill in the blanks. Everybody assumed he was right. So everything they construct after that is going to reaffirm the bias. If you don't understand
if I come
that,
up with a coordinate system based upon that assumption,
if you don't
it will
understand that
fail
it's going to be
miserably.
simply,
Hold on, let him
It
finish.
will fail.
if you don't
Who,
understand,
me or him?
if you don't
Wait,
understand
Travis.
again, that it's,
Let
I'm
Moyak
almost
was
done.
in the middle. Let him finish.
I'm almost done. It's
I thought you were
confirmation
done,
bias.
and then he started talking.
Okay, it's confirmation bias.
Okay.
Go ahead, Moyak.
So we have different methods of doing this. They all work on different principles. So I mean, even if the refraction, blah 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 blah, ether, wind,
Blah, 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 blah. Say it again.
does. Okay.
Come on, guys. Let's try not to interrupt each
Oh,
other.
come on, Brandon. Blah, blah, blah,
I
blah,
don't
blah.
care. We hear each other say ridiculous stuff. They hear us. They think we sound ridiculous. We hear them. We think they sound ridiculous. Let's just try to.
Fair enough.
But I understand
Keep on going.
the temptation, and I
So
fall
we're
into
doing
it myself.
We're doing this by vastly different methods. The assumptions are all different, but they all come with the same answer. Now, Travis said something about the assumption of this Earth being a sphere. Well, that's cool, and it initially was purely an assumption, but then we came up with a coordinate system based upon that information. latitude, longitude. Now, latitude and longitude based upon that information will mean that I will see this many degrees elapse if I'm going around a sphere, and therefore I can tell distances between objects. That still all bears out. It does not, I can't think of any way that you can mathematically take it.
Moyoc, do you think that it all bore out within the first try? Or do you think that they had to continue refining their system and fine-tuning it? Again, you're missing the point. It doesn't matter if you have 5 different ways to Sunday. If you assume your major premise is true without having verified it, then all you're doing is confirming the bias by creating 10 different ways to Sunday.
False.
It's not false.
Because the premise that once I come up with a coordinate system that is a spherical coordinate system, and it yields every time somebody goes out and navigates, they find their location.
Okay.
It is an accurate system. It now bears out that the radius and the circumference, the assumptions are all correct.
Yeah, and the very fact that there are 5 different ways, that negates any bias. You're using different methods.
No, okay, again, I'm just going to end up repeating myself, okay? So I understand that you don't concede that those 5 or 10 different ways are confirmation biases. I get it. I get that you can't concede that. That's just going to be
how they are.
I'm going to repeat myself. Would you like me to repeat myself?
Chris, can I just ask one thing? Just, Travis, I don't want to get too far in the weeds, but latitude and longitude is a 2-dimensional system.
Yep.
Not
Yeah.
three-dimensional.
Which was invented by...
it's not spherical. It's not spherical.
It doesn't
Look
give
up-
the same results on a
dimensional.
flat surface, though.
Look up Eratosthenes. He was the guy that invented it on a flat surface. Look at his map.
It does not give accurate results on a flat surface. If you could
Exactly.
show me a map, if you could lay
Did
out a
you
map,
try it?
prove me wrong. Yes, I've seen it tried. I don't see how it works.
We have done it in the flat 1,000 ways. Blah 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 blah.
If you only have one way, if you only have one way to my house, like across the street, and that's the way to get to my house, and that's the way it is, who's assuming it's round or flat but you, Stooge? The way there is the way there. It's going to be the same amount. So what the fuck? How you getting the differential of what you guess it is?
Because the degrees bear out. When I get into the when I'm in the northern hemisphere at 45 degrees, or in the southern hemisphere at 45 degrees, the distance units east to west are the same.
Why are you
And those
saying
distance
hemisphere?
units are based
You've
upon
already got
observation.
the idea.
Hold on.
You should do it in
He's saying hemisphere. He's already got a sphere in his head.
Right. You should
Doesn't
do it in
matter.
feet from my house to your house, degree boy.
Do it on a flat
work.
surface. You show me one fucking way of laying this out on a flat
Every
surface,
map you've
and
ever
I will
opened
have
the map
it show the
list.
same results. I can look at
Every
a map,
map you've ever
in
seen
the
is
form of a
stupid.
globe, and that map in the form of a globe, I can take it, and I can take a piece of shoestring, a piece of dental floss, and I can measure any distance on
I told
Earth
you we already know the
with
distance.
the
What
dental
the fuck
floss,
is
and
that?
I can tell you the distance between those objects. Now, make a paper map, a flat map, do the same thing. You cannot do it.
Blah, blah,
It
blah,
will not happen. Blah, blah, blah. That's a wonderful answer.
So
Yeah, but you
I want to go back to something you said. You said it all works out on a spherical reference system. So I assume you're talking about looking at the sun and the stars to calculate the latitude and the longitude. Is that right?
Looks
Did he
like
drop
he
out?
dropped. Yeah, it looks like he did. He might have just gotten disconnected or something. So
Uh-huh. Let me read these super chats then. Earth is life. What assumptions does the flat Earth make? None. That's, at least for me, that's the point. That's the whole point. Is to not
I
make
just like his
assumptions.
dartboard that works out not on a flat surface. His dartboard doesn't work out. Works out great. That's how we make dartboard.
That's how we got into this. Hold on, that's how we got into this mess in the first place. Is they started making assumptions and then building off that when their assumption could have been wrong.
Right. Exactly. That's the problem I have with all these crazy assumptions. Brian's logic 499. The two-way speed of light is based on 4 pre-assumptions and 2 averages. There is no one-way speed of light measurement, so there can't be a two-way. Thanks, Brian. Appreciate that. Thanks, Eartha's Life.
You're cutting out.
You're cutting out to me.
Repeat that last one.
The two-way speed of light is based on 4 pre-assumptions and 2 averages. There is no one-way speed of light measurement, so there can't be a two-way.
Right, but now that is an assumption. But are you going to say that you really believe that light teleports in one direction and then reflects back slower? Do you really think that that's happening?
That's what happens with
even
sound.
Hypothesis.
There could be a direction.
Does it not lose momentum?
Yeah, that's what happens with anything else. You throw a ball against the wall and it coming back, it'll be slower. Like, pretty rational, I would.
And even if it was, the round trip delay ends up with a round trip of X time. So we don't even care about that. It still tells us a distance. And it's used
Does light bounce?
Yeah, it'd be a different distance though if it was
Nope, same
twice as fast there and then half as fast back. Yeah, it would be.
But that's
Come
not what
on,
bears out.
figure it out.
Everything we measures accurate to a round trip delay of 186,000 miles per second, or slightly slower in atmosphere.
No, you don't get that. Matches the figure, yes. But if the speed of light was different in either direction, yeah,
So
faster in one or than the other, the distance would have to change necessarily.
Yes,
Not to mention that we can. How can we tell that it's reaching the actually objective and not bouncing out of something else?
Exactly. How do you know that the reflection could be fighting itself in the first place?
You can really kind of tell because it's like assuming that there's a dome or something that it's reflecting.
Kind
off
of really tell.
Well, when I shoot at the moon and I miss the moon, like I set up my gear because it's usually kind of big equipment you set up, big antennas, and I shoot at the moon and I miss it because it's an hour too early. That signal never comes back. However, when the moon moves into position, it comes back. So, and when it passes, it doesn't come back anymore. So we know that it's highly likely that it's coming from the moon, don't you think?
Yeah, no, I don't think you got what was said. If the speed of that radio wave was getting to the moon quicker in one direction, but there is something resisting it coming back, or it loses momentum, i.e. halves the speed of light, yeah, then the distance would be different. It would have to be.
At the moment, we see light seems to go there and back at 186,000 miles an hour.
Yeah, no, that confirms the bias. That confirms the assumption. Yeah, that confirms the assumption. Yes.
Looking at aircraft 200 miles away, or when we're looking at a satellite 2,000 miles away, or we're looking at the moon, it seems to bear out the distances in question. I don't know where you find this possibility. I mean, maybe the moon has a magnet that holds light back for a split second, and the moon's only 50 miles away, but I don't think that's something we can assume until you come up with physics that can accomplish that.
Okay.
Did you say a magnet can hold the light back?
No, I said it, but I'm saying, hyperbolic.
Oh.
But yeah, to answer you, and also to back up FED, and also to answer RC Meisty, all in one, the cosmological constant is part of Einstein's field equations. Einstein is known as Einstein's biggest blunder, and it's nothing major. All it was set to 0 because he put a component in there to say the Earth could be expanding or contracting, but Einstein's own belief or assumption was that it had already gone through all necessary expansion and was settled in a steady state, a static state. So he set it to 0.
What does that mean by contracting?
Yeah.
You mean the surface of the Earth is shrinking and growing?
No, this is the universe.
Oh, the universe. Okay, I thought you said Earth. Okay.
No, this is either way. The Earth is actually expanding and contracting, but that's another story. Either way.
By how much?
quite a bit. You should look it up, but don't distract the topic. The answer to that is that he made that blunder, and we calculate later that there is an expansion of the universe. Obviously, later Hubble constant, and that was what FED said all the key words, but everyone still then kept on asking for the same key words again. The cosmological constant, okay, is the outcome of dark energy. Dark energy is required to explain this mysterious expansion of the universe. Now, what's actually happened, and he rightly said that the Hubble and the Planck satellites have both done measurements of how fast it's expanding. Yeah, and
I'm kind of a lot closer
wait there. They both come up with two different measurements, and that was the assumption. So they're both using light. Put it that way. That's the mechanism. That's the measure.
When you guys are done with this, I got something.
I'm a lot closer to home with what we're talking about, and I don't know why we've gone off the Hubble constants at this point.
Because if I was to say to you, I've just measured the whole Earth using a 1 meter ruler, and I measure it to be net flat. There's obviously hills and mountains and whatnot, but everything turned out to be actually flat. There was no curve in sight. What would you say to me?
I'd say,
let me see that stick.
Wait there. So it's a 1 meter ruler. Yeah, and I've just physically measured the whole of Earth completely flat, net flat, with all these hills and valleys.
That, but okay.
Okay, well, the reason how I did that, because my ruler is not big enough to measure curvature, is it? That's an impractical size ruler to measure the Earth. Yeah, if I want to measure Earth curve, I need something 3 miles long in a straight line, don't I, to measure that curve. Now, that is what I'm trying to tell you. Your measurements on small scale using speed of light, yes, they're going to figure out to be roughly approximately the same all the time, precisely the same. Hang on. But when you test them at long scale, they fall apart.
But we have a back check. We have a back check on that for distances like to the moon. I mean, I'm not the galaxy. Everything that you want to tell me about the size of the universe, I'm going to say I take that with a grain of salt. But distances to the moon is not even something that I would put in. I would put 5 nines accuracy on that.
Yeah, it's all congruent.
Before Jeremy moves on, I just came in. Hello, everyone. I just came in for a minute just to add clarity to my super chat. Because I know Jeremy, I just heard Jeremy say he wants to bring up something else. So very quickly, I'll add clarity to it. Okay, there's 4 pre-assumptions and 2 averages goes into the claimed two-way speed of light calculation because there's not a measurement. The 4 pre-assumptions are as follows. The first pre-assumption is that you're on a globe. The second pre-assumption is that it has a measured radius value. The third pre-assumption is that that globe goes around the sun. And the fourth pre-assumption is that, that Kepler's analemma was correct. So the 2 averages are the average radius of the globe Earth, which is 3959 miles. And the second average is the average distance to the sun in the heliocentric model, which changes from day to day over a 12-month period. But all that is just calculation based on pre-assumption. Hang on, I'm not finished. All that is pre-assumption based on calculation. There is no one-way speed of light measurement, ever. Even Einstein basically admitted it. So nobody has, hang on, be quiet a second. Just let me finish. You can say what you want after that. So nobody has ever measured that. It doesn't exist. Everything else is just calculation based on based off of belief of a model and pre-assumption. That's it.
So your pre-assumption right there is that no one's ever measured it. Thank you.
I'm not pre-assuming anything. If you want to find me the one-way speed of light measurement and who did it, you're welcome to present it to the world.
Won the Nobel Prize of Physics.
Yeah, well, there you go. Exactly. I mean, can you present that? No, because it doesn't exist.
Well, we assume that light travels in a uniform speed. I mean, that's a bit of an assumption too, because light can speed up or slow down, as has been shown experimentally in different conditions. Even though we see what appears to be open, empty space, it may be traveling at different speeds in different conditions on the way to and or back from the source. And since we can't track these light beams, how do we know that this is even the beam that we originally sent out to time for travel? We we can't even know that. A lot of this is highly theoretical.
Secret.
Let me read something just so people don't think we're bullshitting here, and then I'll let you guys go back to it. This is from the Wikipedia page on one-way speed of light. And if you've got a source that contradicts this, let me know. But it says, experiments that attempt to directly probe the one-way speed of light independent of synchronization, meaning shooting at something and back again, have been proposed, but none have succeeded in doing so. Go ahead.
You're lagging a little bit. Repeat that last sentence.
Am I lagging for everybody, or is it just Jeremy?
Yeah,
I think it's no, for everyone, but it's just what the last sentence was like the part that was unclear.
Okay, all right.
And keep in mind
experiments
that
attempt to directly probe the one-way speed of light independent of synchronization have been proposed, but none have succeeded in doing so.
well, keep in mind that light is a waving undulation within the ether. So potentially these ripples and waves could come anywhere from within the pond of energy that is all around us. That's why they're asking for a one-way speed of light, because these ripples could come from anywhere at any time by induction. You can simply, make space, make light waves that just, seemingly spontaneously generate and come back to you. And so we don't even know if the photon, or whatever the heck we want to call light, is the original one that we sent out that is actually coming back to us, and or if there's just this ripple effect that's being induced from somewhere out in space and coming back to the observer. This is highly experimental, and so we might need to look into other theories as well.
Yeah, that's a good point. That's a good point. That brings me to the thing I wanted to bring up, where this speed of light thing is just a calculation. So is the density of the air in our atmosphere. They say the air down low is more dense, and the air up high is less dense. However, if I were to hand you a fixed volume of each of those airs, and you didn't know where they came from, you would not be able to tell me which one's more dense or less dense unless you weighed it. According to our George,
you can just do a chemical analysis.
According to our
George, you get that. You can just do a chemical analysis on the sample you gave me.
And since we can breathe what's down here, it does appear that there's more of whatever we're breathing down here than up there.
So regardless if we can't measure the one-way...
Because the chemical analysis is less work than just weighing it.
Earth is life, your mic's shit.
No, weighing it would obviously be less work.
It was sarcasm, bro.
How would a chemical analysis... What would a chemical analysis tell you besides what the chemical composition of the volume was made of?
The chemical composition will tell you which one's higher and which one's lower, based off of the differential.
How much oxygen is in there that we can breathe versus how much oxygen is in there that we can breathe up high? They say that there's more stuff that we can breathe down here, so they basically say within the same unit space there's more breathable stuff and therefore higher density.
Why didn't George think of this chemical composition thing? Which one's more practical?
No, I wouldn't say there's necessarily more density, but just the chemical composition, like the it's called the TC or something. Yeah. Anyways, it's the differential of the different gases that will tell you which one's higher and lower, but not necessarily which one's more dense.
More oxygen. If there's more oxygen than nitrogen in one, that's going to tell you which one's more dense.
No, but it just tell you which one came from one higher and lower. It doesn't tell you which one's more dense. You're still stuck with that.
More stuff per unit volume is interpreted as
the only way to tell. So the only way to tell which one's more dense or not, which would be to weigh them.
No, you see how much stuff is in the same unit space. Ideally, there'd be a weight change, but they say that gases are so light that they don't register on a scale. So they say that there appears to be more breathable stuff down here than up there. Therefore, it's probably more dense.
Okay, that's not what they say.
You have a greater density of air at ground level. You always
but the only way to show that would be to weigh it, right?
Hang on, leave me. I'm backing up your argument. You have a greater density of air at ground level, right? If you have less density of air up high, up high, then you have less to breathe. It's not that the composition is different. The composition of air doesn't change, no matter how high you go. I thought before it did, I went looking into it a couple of years ago, it doesn't. there was more air at ground level.
You agree to the pressure rating.
Nitrogen and oxygen are constantly, which is 99%, which we're told is 99% of the full makeup of our air, is constantly recycling with the surface of the earth. So you are going to always, and you have more heat here as well, which creates more pressure. So you're always going to have more. So the only way to really find out is to weigh. You'd have to take them and put them into containers after you've weighed the containers first.
So when you told me a second ago, Brian, that the air at the sea level is more dense than the air up high, did you see the measurement, the weight measurement? Does this measurement exist? Is what I'm asking.
Why are you doubting
density?
it, though,
Are you talking about density? Density.
Well, I'm doubting it because they say hot air is less dense than cold air.
That's true. Yeah.
Just
so where's the hot air? Hold on. Where's the hotter air? Stop.
Analysis.
Where's the hotter air?
That becomes part of convection. No, not to do with gravity. It's convection.
Yeah, gravity is
no, not to do with gravity. You don't know what you're talking about.
It's all relative.
You don't know what you're talking about.
As the hot air goes up a little bit in wherever it is, it'll cool down. It's all cyclical and it just kind of balances out.
Convection is
in general, the air is less dense the higher you go.
For instance, Jeremy,
what makes you think that?
Because in the end, the air is a compressible medium. It's a compressible fluid, right? And the fact that there's so much above it, it'll weigh it down. Just like we have pressure in the water, for the same reason, because it's compressible.
Yeah, but now it's a false equivocation from a liquid to a gas.
No,
it's still incompressible fluid. Incompressible. I mean, they're both compressible fluids.
Jeremy,
you guys are finally getting it.
If you look at weather balloons, they will show that the pressure drops as it rises. The reason the pressure is dropping is because there's less. Well, it's got to do with temperature as well, but it does also less per cubic foot of air molecules.
So the pressure's higher. That doesn't mean the density it's more dense.
Well, there's less density per cubic foot, if you understand what I mean.
As a rule of thumb, more pressure equals more density. Actually, that's true for everything, I think.
Jeremy, I was trying to say that earlier to you. I was trying to say that earlier to you. So it's like an offset. The more increased energy exchange can increase that more vapor pressure, right? So you're going to still have that same effect.
So then in those sealed containers I hand you, you can just say, oh, there's higher pressure, so this one must be more dense.
You would have to test the pressure. You won't know.
Jeremy, in that scale, it wouldn't be measurable really. You would have to have larger volume for it to mean anything.
Okay. So if I go get a container of air at sea level and then a container of air at the top of Everest with a fixed volume, and then I bring them down and I heat one of them up to have higher pressure, you're going to say that one's more dense?
They actually claim
density.
They actually claim that there's a gravitational equation, an Einstein tensor equation, to explain how the kinetic energy exchange will actually add a slight difference in weight, apparently, to your scenarios. So yeah, technically, if it's hotter, it's slightly heavier.
Jeremy.
If it's hotter, it's denser. Okay, if it's a fixed volume and you're heating it up, you're increasing the pressure because the volume's fixed. PV equals nRT. That's the general rule.
Density is within an area. So a cubic inch or a cubic foot or whatever, right? It's the amount of molecules within that cubic inch or cubic foot. So at ground level, there's more molecules within a cubic foot than there is at 40,000 feet.
Okay, if we haven't weighed that, how do you know?
Because we have
by the theory, so they go with it because it's demanded by the theory for the theory to be consistent.
As the balloons rise, the weather balloons rise, the whatchamacallit on them that they have on them, the sensors and the barometers. I have my words wrong. They measure a lower pressure. Now, the lower pressure is also connected to temperature. So pressure and temperature are connected. That is, pressure and temperature are connected. I'm not saying they're not.
You should focus on.
If you're talking about density, you're talking about if you're talking about density of the same gas, so we're just talking about the molecule of air, right? Then you're talking about the amount of molecules within a cubic inch or a cubic foot.
Have they
so that's what you're talking about there.
Have they ever found dirt particles in the upper atmosphere at 40,000 feet?
There is dust at. Do you know what the atmos boundary layer is? Do you know what that is? What that is yeah. But that everywhere has its own local. So you have your own local boundary layer. I have my own local boundary layer, and it depends. In the summertime or when it's warm, your boundary layer will be higher. And in the colder times, it'll be lower. So in the daytime, it's normally higher, and in the nighttime, it's lower. And where the clouds start to form is the boundary layer. And that is where most dust and aerosols and stuff like that is claimed to get trapped. And they come back down with the rain and whatever else. So after that point is what they call it the free atmosphere, but we call it the atmosphere, the free atmos, right? And that's where airplanes fly.
Well,
airplanes fly in the free
there be less particles. Have we actually tested this? As far as I can tell, no.
We've actually tested this. We do it all the time in aviation because with the fewer particles that exist up there, it actually is going to take more. It maintains the exact lift. We get this all the time as you go higher, you have to lean out your mixture because your mixture becomes too rich because there's not enough air getting into the cylinder to be able to combust all of that fuel. So yeah,
I'll prove it to you.
I'll
prove it to you that it happens.
Just really quickly though, Brian, can I just find out why Lemon and Jeremy are questioning that?
He's trying to see if these kills were counting out for density or something like that. But basically, RC Micey and others appear to be implying that practically it was inferred from what happens when you try to combust gases and stuff, but nobody really counted this stuff out or tested it on a deep level.
No, actually, here's one of the things so one of the things that you can do in your airplanes, for example, is you have an EGT gauge, right? And you can actually measure how much freaking air is going into your cylinders versus how much fuel. And so as you go higher, guess what happens? You get less air that goes into your freaking cylinders. That's why you have to
Jeremy, was the question how do we measure density?
No, it's how do you know
your
that
question?
there's less air?
I didn't know your name was Jeremy, bro. Now I knew.
You gotta remember that the density has to do with the volume available.
Well, let me just say, if that was the question, the answer is you don't measure density. Density is always calculated, okay? Because it's using the conception of mass, and it's always calculated in that regard. If you have a fixed volume, you can know your volume. The mass is a conception. It's how we quantify matter. We don't actually measure matter. We just have this, the periodic table of elements. It's based off of carbon, and so it's relax, bro. So it's a calculation. In terms of how we know it's more dense the lower you go, it's because we know we can measure pressure. That's the thing that we can measure with like a barometer or what have you, and we know that pressure and density are inextricably linked, especially when you have a fixed volume.
But percent, you're ignoring what I said originally. It's not we actually know.
I'm going to back up what you're saying. I'm backing up what you're saying. Right. Commercial airliners, when you're in a commercial airliner, you are not in 14.7 psi. You're in 11 to 12 psi. The reason you're in 11 to 12 psi is because the lower pressure they're flying in, if they have 14.7 psi, they're going to be putting pressure on the structure from the inside out. So they have to bring down the amount of pressure for the cabin and crew within the airplane, but also have enough in there to be able to deal with the outside pressure. So they have to find a good balance. They would actually, if it was just the outside pressure, they would bring down the inside pressure even more, but they can't do that with people on board. So the average pressure is 11 to 12 psi inside a commercial airliner. And the reason they do that is because the outside pressure is less. So they can't have 14.7 because the 14.7 will be too much of a differential from the inside to the outside. So that's something that would definitely support that claim.
Máximo. Mami, ¿para qué nos arriesgamos, mi corazón?
Sincero.
Hola, mami.
Silent Zero. No somos tu papi. Ni tu mami. Yeah, but Lemon, I mean,
but if you use calculations of PV equals nRT and only change the pressure and Avogadro's number to see how many molecules or whatever their theory dictates be in the unit space or whatever, you'd go down from 14 psi, I guess, for the pressure and go down by a factor of 14. So if you take 6.02 times 10 to the 23rd, which is roughly 602 sextillion numbers of atoms for Avogadro's number, and divided by 14, you just go to like 0.43 times 10 to the 23rd, which is like 430 quintillion numbers of atoms or something like that. So it's still a lot of atoms per unit space, but supposedly there's less atoms per unit space by their theory. Whether or not they've actually fully tested this and counted them out like pennies or like marbles, that remains to be seen.
Lemon, it's not remain to be seen. We know that there are fewer molecules up there because when we go up with our engines, we measure less air per cubic volume. Lemon.
That's fine, but we need to count this stuff out.
Hey, Lemon, don't stop being nervous. Just let me finish. So, we measure less.
Have you met Lemon? He's never nervous.
You're talking about RC Meister. Don't.
We measure less volume per cubic meter coming into our manifold, and because of that exact measurement that we get exact mixture controls that we, as the freaking pilots, lean out. So yes, not only do we measure it every damn day.
So we're inferring a lot of ISD, which is fine, but originally we started on density, which is the amount of stuff per unit volume. So what stuff did we measure? We didn't measure any stuff. Pressure, and then we inferred that the pressure was lower because there's less stuff coming in, less atoms, less whatever. Is the inference justified? Maybe, but it may or may not be. Let's look deeply into this whole theory.
Lemon, I just told you we measure exactly how much is going into our manifold. Not just by pressure, by actual detonation.
Well, let me put something forward. When they're sending up weather balloons, right? Anyone who's ever done it will know that the helium, you don't fill the balloon to its max. You leave the balloon, you just fill it enough for it to start to rise. Because as that balloon gets up higher and higher and higher, that balloon will expand because there's less pressure on the balloon. So eventually that balloon blows at about 20 miles.
But Brian, the problem with that is that it's still based on pressure. Lemon's objection, which is an interesting objection, is, hey, but what about, are we actually measuring the actual molecules? And what I'm saying is, like, yes, we are measuring those actual molecules because we need to know how much air exactly is going, not just the pressure, we need to know how much freaking air exactly is going into our manifold so we know how much fuel to put in, right? And if you look on any freaking general aviation aircraft, right, that's a piston engine, you will see a little red knob. That little red knob, you twist it to the left, you get less fuel. If you look up right above that, there's an EGT gauge. It's going to tell you exactly how much should you be leaning out. That's based on how much freaking air is actually in the cylinder. So, Lemon, to bury your point here, we know that it is fewer molecules, not just less pressure.
We infer that because of our dedication to atomism, which is
don't infer
counting out these pebbles. That inference may possibly be unjustified, density-wise, molecule-wise, atom-wise. I get your inference, and I agree with it for the most part. But unless we're counting out these pebbles, RC, we're just making inferences based off of our atomistic theory.
Clement,
A
it's not.
GCMS.
What I would say is that
a GCMS does count the atoms and molecules, and many people have run air samples in those, including myself.
What I would say is that balloon won't
Avogadro's
expand
number in
if it's dealing
calculation.
with the same
No, it's not
density
a count.
of
It
air.
literally counts them.
It's Avogadro's
What I would say,
calculation,
Doesn't
probably
use
by computer.
Avogadro's number.
I
It's
don't
no
think it's what.
calculation. It counts
Okay,
the
so
number.
how does it count them? Does it pick up each molecule and drop them in a jar? How? Take me through the mechanism that shows me that that's actually the case beyond the theory.
So you put your sample in a chamber and it will ionize the sample. There's a hard ionization method where it'll smash electrons into it and knock one off to ionize it. Or you can do a soft ionization, which is where it attaches a hydrogen atom to the gas molecule. Then, once it has a charge, it sends them around a magnet, because magnets move charged particles, and they, depending on their, they will move in a different path compared to other gas molecules, because they have different masses. And where they hit the sensor, it counts each spot. Every time a molecule or atom hits there, it registers that and it counts it.
well, I would
And then
call
it
that
gives
more
you
of a calculation.
It gives you
I
a
would call it
graph
more of a
that has the
calculation.
mass to charge on the x-axis and the percent abundance, or the number of molecules that hit that spot, on the y-axis.
Well,
it sounds like you're talking about charge being translated into basically what is it?
No, it
Electrons or
ionizes the
coulombs
gas
of force.
particle and
Sounds a
sends
little
it
bit like
around a magnet.
calculation and transferring the proposed charge that you're measuring on the instrument into calculations of individual electrons.
It's called GCMS.
I don't know if I call that counting each one unless you go with atomistic theory, but I could be wrong.
Yeah,
well, what I would
it
say,
takes the sample and ionizes it, puts a charge on it, and then sends it through a magnetic field. And because each gas molecule has a different mass, CO2 has a different mass than O2, has a different mass than SF6, different mass than radon gas. So it sends those through a magnetic field, and they take different paths because they have a different mass. And they hit the sensor at a different location, and it registers each time, each spot, it'll register where a molecule has hit there. So it's counting them in each spot. It tells you on the graph.
So you're taking charge and basically translating it into electrons or coulombs of force, I assume.
No.
Interesting.
You
I
ionize a gas
particle
and send it around a magnet.
It seems to be a bit more of a theoretical calculation still.
There's no
but
calculation involved. You ionize a gas particle and send it through a magnetic field. That's all it does.
lemon board, at 10 miles up, the temperature is minus 51 degrees. Now, it increases after that. It increases after that for another 20 miles. But the temperature at 10 miles up is minus 51 degrees. So it is very likely that there is going to be a less density of air up there. Because a balloon, these helium balloons, they do eventually explode. They do expand and explode. And I don't think they could do that because air, like gas is gas, right? Whether it's warmed up or cooled down, while it's still in the state of matter of gas, then it's still going to behave as gas. And I don't think that the helium balloon could end up exploding. The weather balloon could end up exploding at 20 miles up if there was enough density of air up there, even if it was cooler air. I don't think it would be. I don't think that the helium balloon could explode if that's the case. Now, I'm open to being wrong about it. I don't know. I'm not the
Sound check. Well, it appears that we just lost our feed from Discord. Let me see if I can Okay, well, we've got the microphone back, so that's a good thing. And hopefully Discord will come back too. You should be able to hear me now. I think I just heard a little beep from Discord. Hopefully this is working again. And
do you think that there would be a point if it was to fill that available space as it moved into it? Would it be able to collect and get denser due to the temperature, like let's say extreme cold? So let's say you had the process of entropy, but as it proceeded to expand outward, it would get colder and colder. Therefore, condense it and slow it down.
You're asking, is that possible?
Well, that's what I'm thinking. That's what's happening, right? You have helium, right, that goes up there, and helium is really compressible when it's cold, right? And I'm just thinking, as the process of as it expands outward, due to entropy, it gets colder and colder. So it's still there. It's just, I don't know. It just makes sense that it would slow down and compress at a certain point due to temperature, right? The colder it got, I don't know.
anyway, so I'm not sure I followed what you guys were questioning, the argument that you guys were making. Do you think that there's the same amount of molecules up at altitude and just less pressure? Is that
No. Just I'm just trying to think how other gases, if gases are separated due to the differential pressure based on its matter, then is there a point where that matter gets so cold that it condenses back down, just like the natural cycle of the evaporation, right? Just trying to think of that.
Oh, gotcha.
Coming to do with being really extremely cold. It's just a different gas is responding to the cold differently than we can simulate here on Earth because it's extremely cold. Or we have ideas of superfluids and so forth, like quantum locking, right? Or like supercooled magnetism. But that's magnetism like congealing together under extremely cold conditions. I was just thinking how there would be a way to have a barrier, let's say, like the ocean between Pacific and Atlantic Ocean, right? There's a barrier there, and it's based on temperature and density, right?
What do you mean there's a barrier there? Like where the waters come together?
Yeah, you ever seen that, right?
Yeah, I think I've seen that with different rivers and stuff. I don't know that I've ever seen the Atlantic and Pacific one.
So
but, the Yellow River is like that.
So it separates based on density and temperature.
Isn't it one of them like a little brownish and the other one's a little blue? I think I've seen a picture of that where the oceans meet.
Yeah, something like that. I don't know where that is, but exactly. But
anyway,
yeah,
my
the
point with
Danube
the
River is
pressure.
like that too.
So you can still pass through it, right? You can still, it's permeable, but there's still a barrier there. So
My point earlier with the pressure and density and shit was if the only way to know if it's more dense is to measure it by weight, then let me see it.
Did you happen to hear what I said, Jeremy? When I was explaining the whole GCMS thing?
No, I don't think so.
All right.
Is it a weight measurement of gas from one place up high and one place down low? Because George said that's the only way that you would possibly ever know which gas was more dense.
Well, George isn't a chemist, so he probably doesn't know about ways you can do it in chemistry.
George has been on this earth a long time. He has ancient Chinese wisdom. All right, I wouldn't go questioning questioning George.
I
Hold
explained
on, hold on here, Jeremy. It was for the test that you were proposing, that where you have two vessels, you're going to fill it with air. How would you figure out which is more dense? I wasn't going into any chemical analysis or anything like that,
That's
or any
not-
other techniques. There are more techniques. We were just trying to find a simple way in which you could do it by weighing the vessels. We weren't going into any exotic measurement methods, which chemists have developed. There are many ways you can do it besides doing what I had proposed. It was just a simple little test.
Let me down, George.
Sounds like you're trying to
Let me
obfuscate
down.
something, George.
Oh, come on, Brandon. It's not obfuscating. Jesus.
You know how
Have you got
Brandon knew you were
ancient
trying to
Chinese?
obfuscate?
Come on, Brandon.
You know how Brandon knew you were trying to obfuscate?
Jeremy, would this work? Would
Don't
this
be an
work? You know how
SOB.
gas
George,
would
have you got
gas
ancient
the
Chinese
rate
wisdom?
the rate of gas escaping,
And
right? Or how
Russian
fast it would,
and Greek.
Jeremy, if you were to rate the gas density based on the release rate, like if you brought air from the ground and you brought it up and released it, and it would escape fast, right? And then if you put air from above and brought it down, air would rush in, right? Is that kind of the reality between the two pressure?
No, I don't know. I was
Why
just
there'd
making
be-
sure. I just want to make sure because their whole refraction argument is totally based on this light bending down thing towards the more dense medium. So I just want to make sure. That's all.
Well, increase vapor pressure, right?
Because they'll say the more humid air, the less dense. The more hot air, less dense. But then they're saying light bends down towards the more humid, more hot, more dense air than the cold air. So I don't know. It's counterintuitive to say the least.
Gravity.
The vapor pressure, right, between the energy exchange. That's what you're talking about when you observe these effects, right? But did you know that you can get refraction without energy exchange, right? That's what the issue is. So you're saying that it's going through a dense medium, therefore refraction. You're saying that you cannot believe the atmosphere to be less dense because of all the vapor, or is it more dense because of all the vapor? Because what I understand is more vapor, more kinetic energy is more dense. That's kind of what they're saying.
No, they say the more humid, the more water vapor in the air, the less dense it is.
See,
You're wrong, Data.
There would be no need for the tensor equation for Einstein to create that kinetic energy equation to give. I'm just saying
the Glover's claim is this is the mainstream claim that the more water vapor, the more humid air is, the less dense it is.
Then why would Einstein have a tensor equation to explain the
I don't
opposite?
know. Why would Einstein? I know that. You were bringing that to one of the Glover space-time suckers.
Well, it disagrees with that because it's saying that kinetic energy can add actually a little bit of weight. So if that's true, then there's still some form of density, right?
You got to bring that to one of those flux capacitor time traveling Glovers that's in there, maybe.
A tuning fork. Everybody should own a tuning fork.
Hey, Jeremy, watch your mouth, man. No cussing.
I'm just saying, I don't know why Einstein made up this tensor equation. What the fuck?
Well, it according to the measurement, you can actually measure to the nanometer apparently, and it's very insignificant at small stages when it's measured.
I mean, if we're going to talk about
environment.
assumptions, how do you know Einstein could even spell?
I'm just repeating what I read, right?
I mean, who was William Shakespeare? Talk about assumptions. Welcome to life on Earth.
I'm just being the devil's advocate against.
I'm not
Jeremy's
hassling
argument.
you. I'm just saying if we're going to talk about assumptions like density layers and what air is comprised of in the upper atmosphere is one of a multitude of assumptions we all hold.
Huh. What is Meryl? Is he a man? Is he a talking dog?
I'm just a human being like you, Georgie boy.
Well, that's an assumption.
That's a big assumption.
You're demanding we take that on faith. I've never met you personally, so I don't know this.
Well, you have lightning speed, and you managed to get Thompson's mobile phone out of his hand like lightning. And how did you do that?
I was there. I saw it.
Fantastic. George is a ninja with the Chinese ancient wisdom.
Whoopa!
Good old George. Consistent. Reliable.
Well, when you go to bed tonight, Meryl, you better look under your bed. There might be a ninja there.
I need a little George in my
like
pocket.
a dust bunny.
Well, did we figure anything
That's why
out?
he gets paid the big bucks.
What do you think, Brandon? What is natural to you is the thinner air, like hotter air, if you will, less dense or more dense?
To me, it seems like thinner air should be less dense. Hotter air should be less dense.
So why do you think that they are claiming that refraction is bent down over a larger area of hot air or hotter medium?
I think that they first assumed, step one, assume you're on a giant ball, and then worked everything out after that, just like everything else.
We know there is one interesting correlation if you use straight lines and angles and assume refraction over a certain distance, and it's kind of correlated with that sloping of the ground into the neutral point of the eye, the apparent rising of the ground. The 2 to 4 minute arc minute, if you just calculate over distance and use that straight line, you can usually come up with a feet in inches value that represent this apparent concept of bendy lines passing through a medium.
Yeah, I find it interesting that they rely on this thing called a K value when they do their calculations.
Is that for plane? They also use that K value for the plane charts as well. Is that correct?
They use it for surveying. I'm not sure where else they use it, but for plane surveying. So they'll calculate something and then add this K value. It's kind of a fudge factor. That's what it seems like to me.
Well, this is really what I understand it to be is the concept of an ant trying to find if he lives on a plane or a ball Earth, right?
That's what it feels like sometimes, that's for sure.
Well, if you start out with triangles that make a 90-degree, and then you want to make a new triangle, you can do that. And then you can transpose your other triangle information into the new triangle information, right? So I understand it is as ants trying to find where we are, we're going to use either one or the other coordinate system or geometry. Sorry. And that's, I guess, what they've done with special relativity is they went outside of flat space and went into curved space.
Yeah, to me it seems like what they did was they looked at the stars and they physicalized the ground as the change between your proximity to the stars and their altitude above the horizon. That change and they attributed that to the shape of the ground instead of to optics. They could have attributed it to optics and came up with a formula that would have described that, but it didn't fit their Euclidean geometry that they use on paper, which of course works on paper. On paper, it works 100% of the time. But optics is not Euclidean. So when they tried to apply what they saw in the world to their Euclidean trigonometry, it didn't fit. So they assumed that must be due to the shape of the ground. They tell us that all the time. That's why they say, well, we tried a flat model, it didn't work, because they made an assumption that it should work just like it does on a piece of paper when you look out at the world.
And the optical devices we look through our eyeballs is spherical geometry, geoids.
Yeah, and I don't know what that skews. I know it does skew things somewhat. I think people are still trying to figure out what effect that has on what we see. People are still trying to figure out how optics works.
Yep, totally.
Well, they relate it to psychology more so when you do researching than actually the discussion that we're going on. Like I said earlier, weeks ago or even a couple of days ago, I said when I've asked optometrists this simple, and I've asked two, and gave them an example of the ground appearing to rise, right? And of course, I used the hallway example, and then I went to the horizon as the conclusion, you know. And two of them basically said that they've never thought of it before. Right, they're not thinking that far away. They're thinking at this, you know, they're just not there with that kind of thought, except for this flat Earth community, right?
Right.
Isn't that a bit of the same when they tell us that we know how refraction works because we make eyeglasses, and so you know they take what we can do on a small scale with simply reading a book, and then extrapolate that out into the air and think that everything's a one-to-one correspondence, right?
Exactly. And just like with that, when you look out at the world, because of you don't actually have any depth perception per se. It's just the fact that you're putting two images together from two, sensors that gives you the illusion of depth when you look out at the world. But after a certain distance, you're looking at a 2D. You might as well be looking at a picture. There's no difference between looking at a picture on a screen and looking out at the actual world in most respects, which I find really interesting. And if you're just looking at what's close to you, like you do with refraction, and trying to apply that to 10, 20, 50, 100 miles away, however far away, you have to make a lot of assumptions in order to do that with anything. That's what I question.
I'm excited to meet up with an optometrist here in the next week or two. He was working at a Starbucks, waiting for his business to open up and all this other stuff. Anyway, I'm going to meet up with him, and I have a couple of questions to ask him. So we'll see what he says again. But it's a really intriguing thing because that vanishing point is really not part of their thinking, even though they calculate those angles all the time.
Yep. Oh yeah, the vanishing point is really, really interesting. Really, really interesting. What I find interesting is all that information is there, right? It's all there, and that is not a construct. All the information's right there. It's not a construct of the eye. Because we can use other sensors and we still get a vanishing point. So that's just the way the world presents itself to us. When you're looking from one point of view, which is all we can look at from.
Does each instrument have a limitation though?
You will have a limitation, but the angular size relationships between things in the distance. Let's say I can zoom in with a binoculars or a telescope further, but the angular size relationship between the objects in the distance won't change just because I zoom in. It's just like taking a photo and blowing it up. You're just blowing up pretty much a 2D image of something. So that vanishing point, if you zoom in on it, you can still do the same calculations that you could if you're zoomed out. You just can't be as precise. Does that make sense?
Yeah.
Oh, I think that's where they fucked up, actually, is with the vanishing point and their assumption that the horizon always rises to eye level, which I agree, it does appear to rise to eye level for the most part, but I can get the same, and I haven't shared this with you guys yet. I can get the same squared function relationship that they claim is due to the Earth's surface just by aligning my horizontal target above the vanishing point and measuring my drop to objects in the distance. I get the same exact function. Miles per, per mile squared, whatever
using?
function.
Just tangent functions?
I'd like to see how you calculate that.
I will show you, because I was quite surprised.
Function is.
Huh? Somebody said something. Anyway, it's a function of the distance between that horizontal point and the top of your object, or your assumed sight line.
Hey, Brandon, why don't you write it down and then DM it over to me in a file or a picture or something like that sometime when you can. I'd like to see it.
Yeah, I'm gonna have to talk through it and show you guys. But I was surprised because we're not supposed to be able to get that relationship on a flat plane, right?
Well, I understand, and this is the understanding is that at a 60-degree field of view at a 90-degree, it has this correlation of 0.666 degree, right? Whatever that means in that ratio of 60 to 90. That has a correlation to if you took 0.666 and times it by whatever distance squared, you end up with the same drop, right? It's just another conversion of taking degree and what function are you're using? Basic like a cosine equation? What are you deriving the drop from?
I'm deriving the drop from the. Oh shit! I don't know if I want to get
Brandon, rather than talk through it, you can write it down. If you can do the calculations, you can write the mathematics down. And please, this is George. Just DM it over to me in the next few days, and I'd like to look it over.
Send it to George the Ninja
Yeah.
at ChineseWisdom.com.
Actually, the part where I'm getting hung up a little bit is coming up with an equation. And now I can show you how.
Well, then how do you
get
know
the
that
values.
it's dropping 8 inches per mile squared if you don't have an equation?
Because, listen to me, because I can apply it to specific observations. I can show you how it happens, but I can't, I haven't yet been able to say, here's how you can plug in any height, any distance, and apply this calculation.
Well, then you don't have anything. Sorry.
Yeah, neither do you, George. You don't have any of the data that you determine on what massive refraction or low refraction for your observations. So take a hike.
No, I do have something, George. You're going to be surprised when I show it to you.
Well, are you using?
Well, I'm looking forward to it,
Brandon. Are you using the 1 over distance square calculation to do it?
No.
Just are you using a log?
1 over distance squared. No, I'll have to show it to you because I discovered it in kind of a backwards way, so it's hard to describe. But maybe we can talk about it tomorrow. We have enough time.
Fun.
Shit, I guess I could show you. Nah, let's just wait.
Do a good show of it, because at the end of the day, all I can reference is if I'm going to go down the same Euclidean geometry, which that calculation is, it's on a 2D circle. so it wouldn't truly represent the radius of a sphere anyway. But if you were looking at 3D image anyway, but I'm at the point where you look at the basics of what they tell you, how the arc minute of the ground is rising. They give you clues, but as far as me, and I'd have to using Euclidean, I'd have to use the same methodology because it's about optics, which is circular, right? So it's just completely hijacked.
Yeah.
As far as where I'm at, I can still calculate drop based on a assumption of refraction using Euclidean, but it's really just in a hijacking of that 2D circle.
Yeah, this what I'm going to show you doesn't rely on refraction at all. It's all about
Well,
optics. Yeah.
Well, what do you mean? Optics is refraction. Light is put in through the eye, and there's apparent.
No,
there's an apparent.
You're right.
convergence
It's all about It's all about angular size.
The only way of
and comparing 2D Euclidean assumptions against the optics that you're looking at.
like picture plane calculations. Like if you look
Say
at
that
it,
again?
you take a 2D image and you take a 2D image and draw it into a picture plane.
It just
Is that what you mean?
how you look out at the world, and then how you calculate that using a horizontal against the you look through an auto level, creates that horizontal for you, and you are comparing that to things in the distance, and that's all it takes to get this relationship. No, I don't have to assume any refraction to get that relationship. It's all just geometric based on angular size.
Dude, you found a ratio then, or a constant?
Yeah.
Okay, cool. Yeah, that sounds fun.
Sounds amazing. Have you, Brandon? That's fantastic.
Well, I'll show it to you guys tomorrow, but I don't want to get into it right now because we only got like 45 minutes.
So,
but-
Brandon,
Yeah.
what happened with the Ranty prediction? Did it happen? Did it
Dude,
not happen?
you know what? I told those guys I would do it. They wanted me to make up a prediction for this auto level picture that they're going to take. And to be honest, not only have I been really busy, but I just haven't been able to get myself to do it for some reason. You know what I mean?
Right.
It's
Yeah.
just like I just have no motivation to make this prediction for them. And I know what they're going to do. They're going to take my prediction. And what are they going to do with it? Make some videos and say I'm wrong?
Well, if you're 2 pixels wrong, then they're gonna get you on that one. So
Right. And it's all
I don't know.
about how you back up your prediction. That's all.
Well, yeah,
That's
Ru-
all
Ru-
about the assumptions.
Ruhif already has what his prediction, quote unquote prediction, which is the auto level shooting up into space. So they're going to go there and claim that they're going to try to get it. I mean, we looked at the other night when he brought it up. We looked through all of it, and I mean, we were like Lemon and I were both talking about where level would be. I mean, I guess if he wants to call that a prediction, he can, but that's what level is, and he just has his shooting up into the sky. Because the Earth is curving away. And what Ranty actually does when he goes there, I mean, there's so many problems with that, using a lot auto level over that type of distance. And so they're just trying to pigeonhole you, trying to get content, is what I think, is what it seems like.
Yeah, and at first I was like, yeah, sure, I'll do it. But then I didn't have time, and I said, just don't wait for me. I'll try to get around to it, but don't wait for me.
Yeah, because it's like Ruhif has his quote unquote prediction, and then they're going to claim to go do it. So whatever you put forth, they're obviously just going to try to say it's wrong. So it's sort of like, it's just sort of seems like a useless thing to respond to.
Well, I'd rather talk about our assumptions behind the predictions than just showing a prediction and actually trying to evaluate those.
Always an assumption. Always an assumption when you come down to the end of it.
Yeah. That's the thing with this optical drop. You know, I probably say it every show, but they assume that that's what's causing it. I've never seen a picture of any curvature where I could point to the picture and show and say, there's the curvature right there. I mean, obviously, we've seen pictures where there appears to be curvature. There's curve due to the lens, due to fog, optics, different reasons like that, but not Earth curvature.
Yeah, I mean, it's just sort of another version. Like there's like Blackpool Towers at 600 something feet, if I remember the height of the observer, because this is from the P900 Cool Pics, YouTube channel, is the observation point that they're trying to use. And then 1,100 foot, 1,100 foot is the observer, 600 foot is the tower, and the tower is at 26 miles. And then there's mountains in the background at 90 miles. So, I mean, a horizontally level plane would be, roughly 600 feet above the tower, because if you're at 11 or 1,200 feet and the tower is 600, I'm just using general numbers, just rounding them off from my memory. But so that would be what horizontally level would be. Of course, but, Ruhif has his prediction shooting up into the sky, which would be, what he's calculating of a globe Earth would be. And then Ranty's supposedly going to go out there and use a piece of equipment that's not spec'd and designed to be used at that distance whatsoever. And any tiny little adjustment in the calibration can change that, dramatically. So it's
Gio, I've already explained this to you several times. The working range of an auto level has nothing to do with shooting a horizontal and lining up horizontals with the crosshair. All the working spec has to do, the working range is how well can you read a range pole through the scope. And typically that tends to be, for most auto levels, somewhere between 70 meters and 100 meters. You can still use it beyond that if you have good optics or larger range poles with larger markings on it. It just has to do. Range poles are typically in the U.S. graduated in hundredths of a foot, which is an eighth of around an eighth
we don't
of an
need
inch.
to know, George.
And the working range just has
Would
to
you
do
go
when
over
you're
100?
doing a differential leveling, how well can you read the graduations on the range pole? That's all it is.
Yeah, I don't know,
So you're
but something you guys are doing leads you to believe. This is also, if you can see my screen, this is also based on, if you'll remember, their calculations and Ruhif's assumptions. And this is crazy.
The red line.
This red line is supposed to be the bottom of the mountain.
George, I got a question for your measurements that you did. You said you measured the optical corridor, temperature, pressure, and humidity above and below it to get these refraction measurements, right?
George is full of shit.
Yeah, and
did you measure the same elevation above the water?
I measured over several points as I went from the ice level on up over 20 feet in 1 foot increments.
All the way down the whole optical corridor?
Well, at every point that I stopped at, which was at about each half mile.
But once the light started bending from one, how do you know it stayed in that? You said you did it from the ice all the way up to 20 feet?
Along the ice, yeah.
Every
and
foot.
Then as I got closer to the 6 mile target, then I went up higher.
You measured every foot above the ice for 20
Yes,
feet high.
I made a
pressure,
temperature.
humidity.
No, just the temperature. As far as the pressure and the humidity, those didn't change at all with height as I moved the instruments.
Wait,
up,
if you didn't measure, if you didn't measure those, then how do you know they were uniform?
I said I measured them. I just said I didn't have to record. I moved the instruments up to see if there are any changes. all the pressure and the humidities were all the same from the top of the ice on up 20 feet, 30 feet, whatever I measured. All I had to do was really measure the humidity and the pressure, barometric pressure at the target, and then measure the temperature in steps of a foot going from the surface on the ice on up. And I used a thermistor measurement pole where I have several thermistors mounted, so I can just set the pole up and then just take my voltmeter and read all the resistances.
Can we see these thermistors, George?
So what? You're cutting in and out. I can't hear you.
Can we see these thermistors?
Yeah, they're in my videos. Just go to the go to Walter Bislin's site that documents everything and go look at it. I'm done.
I don't know. Saying you measure. Listen, once the light starts bending, you know there could be a vertical, a gradient going left to right. Did you measure that way too? Because Bislin or one of those goofballs that do the curve calculator thing demonstrated that you can have left to right refraction sometimes.
No,
by the time you got from one
you don't have left to right refraction. I've over 20 some observations where I measured horizontal refraction. It's always negligible. Refraction only occurs in the vertical plane, not in the horizontal plane.
That's not true. That's not
Yes,
true.
it is true. It is true.
Go ahead, Travis.
I can show you any moment. Yes, it's true. You're full of shit, Travis. Goodbye.
George.
George, you're full of shit.
What the hell, dude?
Anyways,
You're
I
not
didn't
allowed
mean
to
to cause an
argue with
uproar.
George. He just runs off. You can't say anything. He won't have a discussion.
It's because
with you.
Jeremy told him he had ancient Chinese secrets.
No, I'm not running off. I just mute myself so there isn't any conflict here, and I'm not accused of talking over anybody. Jesus,
I mean,
Paige, get a life.
George, I can show you a video, George, of a half an hour of video where the position of my observation moves laterally across the screen.
Well, I don't believe you. You must have done
It's
something
on
wrong.
my fucking channel, bro.
No, I
It's
don't
on my
believe it.
channel.
I don't believe it. I've done precision measurements using 1 arcsecond theodolites
I'm
to
glad.
measure left to
glad.
right, to measure left to right shifts due to refraction. There never has been anything of significance.
Great, good. You know what that means? You live in a different climate than I do, just like B-Ball does, right? So B-Ball's got this uniform climate that gives him the same presentation every single time. Okay, that doesn't mean that I should get the same presentation as B-Ball in California or Maryland or you wherever you are, right? I didn't say that your measurements were incorrect. I said your conclusion that there is no horizontal refraction is incorrect.
As far as I'm concerned, and as far as I'm making my measures, all we care about are my atmospheric conditions, not yours, not B-Ball's, not anybody else's. My optical corridor is unique to me, and I have the measurements for that optical corridor.
That's very narrow thing.
Yeah, well, then from here on out, just say I have not observed horizontal refraction in my location. Don't say it doesn't happen.
Well, it didn't happen for me. Fine. I have never measured any significant horizontal shifts due to refraction in the horizontal plane at my location.
That's fine. Great. That's fine. I have.
Anyways, I'm not buying that you actually measured every foot up above the ice for 20 feet. Well, you said you didn't measure. You only measured temperature. So how do you know about the pressure and humidity wouldn't affect refraction?
Jeremy, you're not listening. I told you I've measured the pressure, the barometric pressure, and the humidity, and I've taken those instruments up to see how they change with with height, and they never did. So all I do on those is make one measurement at the targets for humidity and pressure. That's sufficient. The temperature I measured to see if there was some sort of a gradient with height.
Did I get disconnected?
No.
What have Travis measured? I heard he measured something.
No, that's not what I said.
Child. Thank you.
You're welcome.
I got disconnected.
Chikey, how many observations do you have to show us? How many hours and days of footage in different locations and the same location have you done?
None.
Thank you. Geo just posted this, I guess Ruhif posted. This perfectly summarizes the assumptions they make. It says curvature of the earth. Without the interference of refraction, so just take refraction away, the line of sight on a leveling instrument runs straight along a continuous horizontal plane. However, because the earth is round, the ground curves away from this horizontal plane and the gap between the two increases. This is known as curvature and results in the staff reading being too high. This error is also magnified over longer distances. It's another reason to avoid taking level readings at distances greater than 100 meters. See, short distances, you're going to get the same answer. That's another thing I'll show you tomorrow why that is. Calculations for refraction and curvature error are usually combined. That's true, but there's two distinct calculations that you're doing and combining those. You're doing a calculation for refraction and you're combining that with another part of the calculation for curvature. So they are two different sources of error that you use.
Just the wording there is.
Oh, did you say 100 feet or meters?
Meters.
100 meters. And George is looking 6 miles and saying this is okay?
26. Well, the one that ran 26 miles.
Yeah, but you noticed that he had the qualification that you had to intensify your scope and also make your poles larger so you can see them. So as long as you make those...
That's if you're doing a differential leveling. I'm not doing differential leveling. I'm not doing leveling of any kind. All I'm doing is looking through the scope to see a horizontal. It has nothing to do with the working range. Oh my God, I've said this at least 10 times in the last couple days.
Yeah, and you still think that you can use these tools
Why would
to
you
look
use
over...
the tool more than 100 meters in the first place?
That's a good question, Rob. Very good question.
Because you can't. Where are you getting the 100 meter? Where are you getting the 100 meter limitation? Where do you get the 100 meter limitation?
Brandon just read it.
Read it again.
Let me ask the question again.
Read it
what
again.
purpose is it to use the tool more than 100 meters?
Hold on. Let's let Brandon read it again.
All right. This is known as curvature and results in the staff reading being too high. As this error is also magnified over longer distances, it's another reason to avoid taking level readings at distances greater than 100 meters.
Exactly. That's what I just said. Level readings. I'm not doing level readings. All I'm doing is shooting a horizontal. I said when you're making a differential level measurement, if you're doing differential leveling, you have to take the Earth's curvature into account if all you're doing is shooting one direction. But if you're doing a differential leveling, the curvature of the Earth drops. Oh my God, forget it. These guys are interrupting. I'm out of here.
Yeah, come on, guys. Let's not interrupt too much. What George said was that you have to take the curvature into account. What he means is there is an error when you make these assumptions at longer distances that you have to correct for. And some people out there who are part of a very large religious sect believe that's due to curvature, but it could be something else.
Yeah, I mean, if there's an error and it's getting magnified the longer you go, and they're saying, you listen, 100 meters, guys, let's, keep it within 100 meters, and dudes are out there trying to shoot 6 miles, 20 miles to the fucking sun, that's obviously going to magnify the error.
Yeah, the last
They're
sentence of that is
admitting that
classic. Too. Calculations for refraction and curvature error are usually combined. So they're literally admitting that you have to then plug in these different calculations for quote unquote curvature error. The thing is, this is really the difference between geodetic and planar surveying, because that's the whole point. They make these equipment for doing local planar readings, and then in terms of what they're trying to claim, when you have to put those planar readings into a larger geodetic system, which gets into the globe model, that's when you have to do all these calculations to piece it all together. So it's just like it's right there in plain sight.
you have to bend all the edges of your flat planes. So that's why they have to do all these.
Exactly, and piecemeal it together with calculations that include a radius of the Earth assumption.
Make your disco ball. Yeah.
That's why I think the maps are fucked up and the distances. We can't rely on them. Because when you do this and you make these assumptions right here, the map you put together, well, you may be able to use it for navigation and whatnot. I don't think it's going to be an actual representation of the surface you live on if it's actually flat.
Yeah, some of these guys don't understand how actually easy it is to be able to take. Well, I mean, I'm not saying it's super easy, but I mean, if to take the actual Earth and then to model it together into a WGS-84, you can make flight paths, and you can do all kinds of to convince lay peoples that are not verifying it.
Yeah, and notice who did it, Gio. Who created the WGS-84? The Department of Defense.
Military boys.
Military.
Yep.
Of course.
Yep.
The exact people who would have the biggest motive for wanting to control knowledge of the map of the territory. That go read Sun Tzu and you'll find out how important it is to know the territory. Go listen to any war documentary about Vietnam and they'll talk about what an advantage it is to know the territory.
Yes, sir.
Brandon, seriously though, this is the government and the military. I mean, surely we can trust these people, no?
In my experience, like I've said before, if they told me that I breathed air, I would immediately be suspicious that they were lying. I don't trust anything they say, nothing.
How does the Department of Defense work? How does the CIA work? Like if you are a military and you have the intelligent group, or you are a part of it, Jeremy, how would you go about protecting your location or your spot, or the ability for you to do what you need to do? How would you?
I just yeah, for sure. Yeah, I just posted the who created the WGS-84, which is the Department of Defense, but it's specifically called the National Geospatial Intelligence Agency, National Geospatial Intelligence Agency, which has this CGI, fake sun CGI globe thing as their logo, and they are intertwined with the military, with the NOAA, NOAA. I mean, they are like deep in all of these intelligence.
CIA, SIA, yep.
I mean, if you were trying to control a massive group of people, you definitely would not want to give them correct information at all.
You don't have to control the people, Jeremy. You just control their thoughts.
That's right. If you can control the way someone thinks about the world, if you can give them a false image to believe in, a false idol per se, you can control how they behave, because you can change it at will. If it's not real, if it's not based in reality, you can change it when you need to.
These elite atheist, satanic, demonic lineage motherfuckers that we're talking about controlling the world. Yeah, these people, hold on, I'm right in the middle of my monologue. First sentence. I didn't even finish the sentence. Relax, Strike, you're next. These motherfuckers are doing everything they can to control you. That's their ultimate goal. They know a lot of shit. They've done a lot of shit about learning to control people subliminally, and all that shit. So have no doubt that they will do anything they can to control you, down from changing the shape of the Earth to what you see on TV to everything.
Absolutely.
No doubt.
And just
Yeah,
remember
mono
when they
logo.
started accelerating, when NASA was created, when they started accelerating all this, the moon, all this space stuff really went into high gear and became government domain after the advent of effective rocket and missile technology during World War II. Okay, so at that time it became possible to reach out and touch someone from long distances, and for people to actually go up, it became feasible for people to go up high, to go 60 miles high or however high they can get. That is a huge capability, and it's a game changer when it comes to war, especially total war, which we had just come out of. So they have been, regardless of what you think, been preparing for World War III ever since the end of World War II. So you have to remember that their job is to prepare for total war. And what lengths will you go to protect the people that you care about, or your country or your assets against total war?
But
No,
if
thank
I
you.
want to get a large group of people under control, I get them hooked on crack.
They've already done that too, Chucky. They have fully
Are you hooked on crack?
drugs, toxic
Are you
drugs,
hooked on crack?
I'm not gonna lie.
destroyed people's lives through the illegal, quote unquote illegal, off market underground drug trade. They've completely controlled, and the
Yeah.
pharmaceutical addiction.
I'm not talking about voluntarily. I put it in your drinks, in your
In
water.
the water, like
What do you think the
fluoride.
fluoride is?
Fluoride. Yeah, like
Oh
fluoride.
yeah. You're very hooked on fluoride, right? You can.
It keeps us docile.
Come on.
Listen to this
Shout
first
out
sentence
Hitler.
on the history of this. This, what is it called? Geo, what's the name of this spatial agency? National Geospatial Intelligence. Of course, it's an intelligence agency.
Brendan, can I just address something that Chaiki said?
In a minute, yeah, hold on. U.S. mapping and charting efforts remained relatively unchanged until World War I, when aerial photography became a major contributor to battlefield intelligence. What did I just fucking say? I said World War II, but obviously it became important when airplanes were invented, and then even more important when rocketry came into
comment now.
being. Yeah, go ahead.
Hey, Brandon. Okay, Chaiki just said they're trying to get us hooked on fluoride. Do you think they put the fluoride in the water to get us hooked on it, Chaiki? Is that what you think they did?
I didn't say they tried to get that.
You said get us hooked on fluoride. Yeah, you did.
Well, we said that they're putting fluoride in the water, and then Chaiki said that it's not addictive. Like, you can't get hooked on it.
Yeah. Better listen.
Then why do I want to brush my teeth 30 times a
You
day,
think
Chaiki?
they put it in the water to get us addicted to it? Is that what you said?
But say, like, what's your point about fluoride being addictive or not?
Well, I think Chucky's original point with this is he said
really good
something
point.
like he was trying to say that if he was an evil dictator, he would do this and that. He's thinking about getting into the field, maybe. So he was saying that that he would get everybody addicted on crack cocaine or something, and then somebody brought up, that they are putting stuff in the water that causes various behavioral and physiological deficits in the human system. That's only the beginning. What they're really doing with the food system, the GMOs, glyphosate, Monsanto. I mean, we're talking about hormone disruption, cancer causing, autoimmune inflammation in the body. I mean, that's a whole other topic that is very deep.
Talk to him.
Listen to this. Have you guys ever heard of this? National Photographic Interpretation Center. Shortly before leaving office in 1961, Eisenhower authorized the creation of the NPIC, a joint project of the CIA and US DoD. It was a component of the CIA's Directorate of Science and Technology, and its primary focus was imagery analysis. NPIC became part of the National Imagery and Mapping Agency. The fuck are these guys up to? Anybody ever heard of these guys before?
Their whole job is to analyze images.
They analyze images, man.
National Protection of
shit.
Information. They analyze them so you don't get the right one.
That's actually a good point, Demo. That's a good point. They missed that one on Mars with the mouse or the duck, maybe, but
Dude, Eisenhower is in the top 5 best presidents of all time. Okay, so he's not doing shit, making up teams to fucking fuck with the Americans.
Top 5
Making
that
up
are
teams
alive
to
that's
second-
off one term.
I don't know, man. He made some weird decisions after the end of World War II.
Like what?
How he treated prisoners of war over in Europe. Kind of messed up, but maybe it wasn't all him.
He was one of the best ones, man. And yeah. So him wanting to analyze pictures, it's not. So it's trivial. He just wants to analyze pictures. I don't know. It's not that strange.
Well, it is a little bit, because here's another reason. NPIC first identified the Soviet Union's basing of missiles in Cuba in '62 by exploiting images from U-2 overflights and film canisters. So these guys are involved with the U-2 program, obviously, who was involved with NASA and using NASA as cover back in the 60s and 70s, at least, from what I can tell.
Demont called it.
Deep in
These
the
are
shit.
the guys. Demont called it. These are the guys that analyze the images to make sure you don't get the right ones. Like I said, they missed the one with the duck and the rat on Mars, but they're doing a good job.
Let's not forget it was Eisenhower who made the speech about the shadow government. He was the one who was concerned with the whole idea of the shadow government.
Well, that's
and he was the
convincing.
one warning us about them.
Oh yeah, I'm convinced. He's a good guy.
Yeah.
Damn it, I lost freaking audio. Hold on. I got to restart OBS again. 2-second delay.
Honest scientists with their wonderful satellite data, and they're perfectly mapping the Earth. But in reality, these are intelligence agencies with the Department of Defense and the military, deeply bound within this entire system of the military intelligence agency structure that are, well, the military industrial complex, that are actually creating all of these models and maps and images that they, who knows how many levels and layers it goes through until they release that to the
How many?
Yeah, they're just in a
Who
cult
knows?
following orders. Like,
Do you have any
probably
evidence of that?
you guys,
Yeah, all these good guys, like the ones that
Do you have any
started
evidence? Or
Vietnam.
you just
and
making assertions?
Middle East
Do I have any
wars.
evidence of cult behavior as per textbook cult definition? Oh, I definitely
Flat
think
Earth is
we
full
do.
of cult behavior.
Sound check.
Oh, then there's the projection. That's another CIA tactic. It's really gross,
Oh, we should bring up the
But
tactics.
I was gonna say that
Disgusting.
I was gonna say that degenerate behavior begets degenerate behavior. So I wouldn't suggest anyone on my side play any of those games because
Oh, you
obviously
mean like Jin, Mabbit, Demok?
If you say my name, I'll kill you.
Whoever the description fits, brother. Whoever.
Whomever.
Okay. Whomever. I could never get it right. I don't even, I don't even try because I'm like, yeah. Whom are you
Doesn't work
talking
either
to?
way.
It's
People know what
it's
you're
who?
talking
I don't know.
To whom are you? Who are you talking to?
When it's third person, it's whom, and when it's second person, it's who.
And I don't know how I know when it's right and wrong. I just feel it. I couldn't tell you the rule.
That's what she said.
Hey, Kosho.
Yes, sir.
Eisenhower's in your top 5. Where do you place old Biden in that list there?
He's in my top 50.
All right. No one will admit. Will anybody admit to thinking that guy's doing a good job? I'd love to hear someone admit that they're happy with this guy.
But I'm not paying. I'll tell you what. I'm not paying attention to him. But from my experience, if you don't hear too much about somebody, you don't hear too much about what's going on, it's not really a bad thing. But at the same time, it could be. So I'm just not paying attention. So
You didn't hear?
I
You
did
didn't hear about
hear
this
that.
whole Afghanistan thing?
No, I did, but that's the thing. I don't know the details about it. So, the thing with Afghanistan is nobody
pulled
even
out
knows.
of Afghanistan, and we left them mad stuff, choppers.
No,
vehicles,
nobody even knows why we're
bombs.
there, and the
part of the-
reasons why we're there are so geopolitical and so shadow government that us pulling out or not pulling out, like nobody even knows, the motives and motivations. So it's one of those things.
Well, I think that a lot of it, the reason we stayed is because we broke it, and we were trying to get it to limp along in a functional manner, hoping not to make a new sea of terrorists. And we decided after a while this ain't working. And
That's
even
what I mean.
Trump was going to pull out by May. He didn't, or wanted to pull out by May. So that would have even been earlier. And I guess the biggest problem was we still had, at the time we began to leave, we had left them in place with an army, so you couldn't destroy all the equipment because their army was supposed to, or police, whatever, were supposed to be able to use that equipment. And then they fucking folded like a cheap, I can't even think of the word, but they just collapsed instantly in the face of any pressure. So you didn't get the chance to go and destroy the equipment because you'd left it there on purpose.
Yo, man, the CIA got their hooks into the Taliban. America still rules Afghanistan, man.
Yeah.
That is a possibility. Weren't we paying ISIS fighters to fight against the Syrian government?
Yeah, my enemy is my friend.
Yeah, right.
That's
Why
a
is Syria our enemy,
well-worn
though?
war
I haven't
tactic,
figured that
and
one
it's
out.
the right thing to do sometimes.
I got a phone call, Miss Mark. I disagree with that. That was actually a good example. What Miss Mike said was a good example of what I mean by we don't really know what's going on. What Mr. Mike said is so cover story what's going on. It's got nothing to do with any of that. It's
I didn't say the cover story.
Bro, you're only getting the information. You're only getting the information they want you to get, Kosho. Make no mistake.
Well, sure, yeah, but it's the motivations have nothing to do with our fuck ups or our wanting to help people or anything like that. Our motivations are strictly geopolitical
About money.
And an
agenda
that we would be stupid to even assume because
I said we broke it and we didn't want to leave a sea of shit there, and it became a political thing where why are we staying here? It's not going to get any better. So at some point you got to say we give up. You can't keep blowing people up. It's geopolitically inappropriate to just go in from a war footing. And from a policing footing, it's not great. It's
but we've known it's a losing cause for like
I don't think
10...
it's policing.
Go ahead, Kosho.
It's not police. It's not policing, and it's not. We want to fix what we fucked up. It's nothing like that. It's there's other motives that, like I said, are underneath the surface that we can guess at.
Could you give me any ideas? Because I can't think of what would be a. Afghanistan is a shithole, and it has no resources worthy of note.
No resources.
Opium.
So first of all, it's a path between Asia and Europe. Two is there's lithium. There's plenty of other resources in the mountains. And three is it's one of the countries. It's one of the countries that was outside of the influence of the Soviet Union or the Western countries after the Cold War, which was all those are all. Well, we want them to be under our influence. Right. So I think
we want them drinking Coke and Pepsi, eating McDonald's and Taco Bell.
We didn't push hard for that.
All about the money. Yeah, money's always the motive, though. Make no mistake.
Well, wasn't there a pipeline mixed in there?
Dig down and see where the follow the money is, and you'll see
Taco Bells and Chipotles also.
Yeah, but there's
an
no money
oil
there.
pipeline? Is there a fucking oil
That's
pipeline?
the
Is
only
there
money that they
lithium
got is a
mine?
pipeline, and that's not
All right.
that's not like local money. That's like keeping the world lubed. So
Dude,
I mean,
oil
you wanna
pipelines
have
are a
that
big deal,
pipeline going
Moyak.
to keep Europe lubed.
It sounds like this would be a
that.
big
Keeping the
fucking
world
deal.
loop.
Yeah, it
KY.
sounds like-
Keeping
No,
the
but
world
that's-
loop.
That's what I mean
Come on,
about the
brother.
location. It's location, 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 and Afghanistan is one of those places where it's in that area that is it's not about the pipeline. It's about
It's in the
you
center.
know the path between Europe and
Center of the
Asia,
flat Earth.
and it's mountainous. It's very strategic to
Can't get
either
anywhere without
have
going through there.
not on our side or to have on our side. So it's just
So
one of
you
those places that you want locked down.
So you can't get anywhere without going through that area. Is that what you're telling me?
That's not true.
Not land wise. You can get from Asia.
But nobody
you can get
went
from
that way
Asia
for the
to-
past
You
50 years.
can't get somewhere one way. What a different? Well, hold on a minute. Hold on. On a globe, you're telling me you can't not go across that land?
That's what I'm
Well, if
saying
you
to
want
you.
to take a
You have
400-mile detour,
the Arctic. Yeah, exactly. The Arctic. You have
Anything
the Indian Ocean. Then you have the whole reason we found America was because of the
because it's flat.
the easier path from fucking Europe to Asia. So this is another path from Europe to Asia.
Bro, you do
That's a
not
true story. That's why
know
Columbus.
that.
That's why Columbus was
That's a
funded.
true story.
It's flat, or you would never have to go
It
anywhere.
doesn't matter. It doesn't matter if you think it's a true story. That's the reason why Columbus was
talking
funded.
over
Was
me.
to find
You're not making
an easier
sense.
path.
There's no such thing as an easier path on a sphere, stupid. It's all
Yes, there
equal
is.
distance on a sphere. Show me on a cue ball where there's a better path.
there's
You
land
fucking make no
masses
sense
and
at all.
things you have to go
Show me on
over,
a cue ball.
mountains,
I'm saying
hills, bumps, grinds. And in
Yeah,
the
true
in the
story. Show
time
me
when they
on a
were
sphere.
doing this, why am I even talking to you? You don't listen. You don't have conversations.
I'm not sure about this.
Sun Tzu
It being
said,
that
"Know thy
strategically
enemy."
important as far as a pathway from Asia. I mean, you could still go through Pakistan, who's supposed to be our ally, even though that's kind of a joke.
Exactly.
Turkmenistan, Uzbekistan, I suppose they
Pakistan.
fall under the control of Russia for the most part, huh? Kazakhstan. I don't know how allied they are with the Russians, but Iran, yeah, I guess that's probably why it borders Iran. That's probably one of the reasons.
You ever
And
heard
this
of Wesley?
pipeline, I wouldn't underestimate the importance of that pipeline, though.
On a flat Earth.
Oh, exactly. The pipeline is an aspect of the path thing. But you ever heard of General Wesley Clark?
No, I've heard of
And
on
what
a
he
flat map,
claimed.
you have to go through this certain section to get to the
Yeah,
other side.
after 9/11,
globe,
General
you
Wesley
don't
Clark
have to do that.
he was claiming that there was a memo saying that not only were they gonna go to war with Iraq and Afghanistan, but they were gonna go to war with there's 5 other countries. I think it was Libya, Syria, Sudan, Pakistan, and one more country.
Basically, every country
Either
that
way-
has oil.
Yeah.
Well, no. Look at what it really is. Look at what it really is. What it really is there was the Cold War, which was basically the aftermath of World War II, which was basically the recollection of the consolidation of all those powers. Once World War II was done, Soviet Union and United States were the dominant ones, and they were collecting their umbrellas of influence. And at which case, when the Soviet Union collapsed, it was the United States and their umbrella collecting as much influence that was left over. And the influence that was not that was kind of rebelled, kind of not aligned with anybody, were these countries that Wesley Clark had named, the countries that we've been going to war with. It's just basically influences or countries that don't have the influence of these major powers. And I think what the goal was from our perspective was to consolidate everything else, and then take out all of Russia's allies, and then put Russia in checkmate was the original goal after 9/11. And I think that that didn't go to plan, but they have a similar plan even still. But that was the original plan, was to take out all these countries that were very close to Russia, and then checkmate Russia. I mean, they've done as much since even Syria and shit. So they're still doing basically the
Afghanistan
same
doesn't
plan.
meet that objective.
Well,
yeah.
Afghanistan might have been our foot in the door because 9/11. That's where supposedly the hijackers emanated from. So who knows? But
Saudi Arabia.
Saudi Arabia is already in our umbrella.
no,
Yeah, all
I
the
get what you're
terrorists are
saying
from
though.
Saudi Arabia.
You're right on that front, but it was supposedly planned in Afghanistan, or that's where Bin Laden was based, right? Supposedly.
That's where they were friendly to the terrorists.
We forget we were already
allowed them a base of operations.
Funded by allegedly. Let's not forget
we were
that's
already
all
getting
alleged
influence in
bullshit.
Afghanistan.
People. But they were also, I'll wager, they were funded by friendly groups in every country.
It's
going through the whole
in the 80s.
You have groups of people all over the world, and they funnel money into these groups. So, I'm not sure how in the government how much of Saudi Arabia was actually. Was this a government-funded thing, or was this a?
There's an agenda outside of the governments. There's an agenda that's outside the governments, and when you think of it that way, it doesn't look as confusing to think that Saudi Arabia is funding these terrorist groups like ISIS openly, when you realize that Saudi Arabia and our interests overall are the same.
Are aligned.
Like we actually we have yeah, exactly, they're aligned. We're under the same umbrella of interest and influence.
But the funny thing is, I don't find like it seems like so many people are trying to put a nefarious thing on this. It's like, no, America wants to have secure fuel. I mean, absolutely, you want to have your fuel supply secure. You want to have as many convenient paths for bases of operations and whatever else. These are not
You
like.
want a little cocoa melon? You sick of this
We don't
cartoon yet?
just-
Are you sick of this
You're
cartoon
hot
yet?
micing.
Mike's open, Jeremy.
Hot micing, Jeremy.
Oh, sorry.
No problem. So the nefarious nature of what people are saying, it's geopolitical. Yeah, it is. There are geopolitical concerns, and I don't think that they're terribly secret.
Hey Moyak, here's a fun fact. In 1979, 0% of the heroin in the U.S. came from Afghanistan. By 1981, 90% of it was.
Okay.
Right. So that's another big thing we got from Afghanistan everybody wants to forget about. But Moyak, I don't know how you cannot look at this and go, it's not right. I mean, this is kind of like a greater
Not
good
right? What do you
mindset
mean?
that it sounds like it is coming from you. We destroyed these countries. We killed millions of people.
Oh, it's not nefarious. It's not nefarious. Geopolitically, it's, there's nothing.
Well,
What are you talking about?
I don't agree with Mike's sentiment, but I also don't think that it's evil or nefarious. It's very natural. It's a very if you imagine like a petri dish with different cells in it, and eventually there's gonna be one cell that's dominant.
We are not
it's
bacteria.
Like we're
Maybe
yeah,
you
but
are.
we are. We really are, and
We
we're
act
really
like it.
we're trying to be the dominant influence in the world. And it's not the United States. I think the United States is a tool. The United States is a tool in this. I think there's some overall agenda that we're just part of. I don't think it's United States.
Kosho, based on that, you think that the Holocaust was totally fine?
Branch, I'm glad that you saw that what I said.
Well, actually, that's kind of a good question. I know it's a touchy subject, but Kosho, it is kind of a good question. If it's all just a game to see who's dominant, then where do you draw the line?
It's not a game to see who's dominant, and it's not a justification of what's going on. It's an explanation for what's going on in the context of it's not an evil endeavor, it's a natural endeavor.
Logical
I don't agree
Killing
with
millions of people for your own geopolitical goals, for your own strategic goals, is evil, Kosho. That is evil.
That's why we have conventions
evil,
against
I've
it.
said this before. Evil is when somebody's made a cake, right? Perfect cake, and somebody else comes by and just fucking tosses the cake on the ground just to be a dick. That's evil. It's not evil to do something that you in your heart think is right. So people from any side is going to think what they're doing is right, and to each their own. And then
Wait, what if in your heart you thought cakes were unhealthy and it was right to destroy it?
That's different,
Depends
isn't
on
it?
your motivation.
Different than
Well,
raw
so
dead.
this is like a relativist philosophy you have here. So if I think it's right to, you know, Canada, we could really use that space as we expand. We need room for our people. How about we round up? I think it's okay in my heart. I think it's the right thing to do for my family and my country to round up everybody in Canada, liquidate them, and take over their property and country.
I think that'd be fucked up. But then again, I also think that's what the Canadians did to gain the country in the first place. Same thing we did in America. In America, we came here. There was people here already, and then we took over the land. It's fucked up, sure it is, but it's a natural progression of interest. I'm not agreeing with what they're doing, but I also don't think that it's outside of. I don't think it's extraordinary or anything like that. It's what everyone's always done to gain, you know, resources, power, or anything. It's just a natural progression of things. There's gonna be a time in the near future where there is a single government. There's a single power in the world, and I don't want that to be the case. But I'm not denying that will be the case because that's just a natural, you know, inevitability of how things happen. Someone's going to win.
If you let's say that from my perspective, or from our perspective, Russia's influence is an undesirable thing. So you want to get influence away from Russia because having Russia there gives them a power play on the world that will usher in a bad situation, a bad government, a whatever you want to call it. So we want to try and control that influence. So there are reasons to go there that are morally questionable, but also can be justified in that you think that you're doing the right thing. The ultimate goal is to not have the whole world turn into a shithole.
Has Russia dropped 350,000 bombs in the last 20 years?
Yes, they did it with Afghanistan prior to us doing it.
They did not drop. The U.S. has dropped over 350,000 bombs, something like 50 bombs a day, every day for the past 2 decades. And you're telling me Russia's done something
I don't think that's true.
You don't think that's true?
I think the last 2 years it hasn't been that many.
Code Pink did a study that they released in 2020 where they went back and they used publicly available information to document the number of airstrikes and bombings, and that was the number they came up with.
That's an average. What were the last 2 years like?
They came up with like 300 and over 300,000. It was like 350,000 since 2001.
Yeah, and how many in the last 2 to 10 years?
It hasn't eased up that much.
Well, you'd have to tell me what the number is for the last 10 years, because an average when you're on a war footing and dropping 20,000 bombs a day.
During Obama's reign, they dropped so many bombs, they ran out of bombs.
How many did they drop?
During Obama, there was a point when they were doing something like over 100 airstrikes a day.
And what were those?
You're telling me America ran out of bombs?
And when Obama was in power, they were bombing 7 different countries. They were doing airstrikes on 7 different countries.
Right.
It's not just Afghanistan.
When did we run out of bombs?
We never ran out of bombs.
2014.
I served in 2014. We didn't run out of bombs.
You're telling me America ran out of
bombs? We did. We were. Obama was dropping a lot of bombs, and as I said, you know, Afghanistan was the longest war we've ever been in, and we were doing some machine stuff, but it was, and you could disagree or agree with the morals of it. And I disagree with the morals of it, to be honest. But I'm just saying that it's exactly what you know, anybody else who was up in front would be doing, just because it's what. It's what you have to do to become the number one. I don't think we're going to become the number one. China will probably be the number one.
Kosho, have you ever heard of the prisoner's dilemma? Because this is what I hear you describing.
Mathematical problem.
Right. So what you're essentially saying is it's in our advantage to be the first one to do these awful things so that we can be the ones who control things.
I didn't say any of that, dude. I didn't say we at all.
No. That is where it leads. What you're saying leads. You're saying it's natural. It's natural to kill people. It's natural to do these awful things. It's natural to starve children in Iraq.
Have you ever killed anyone,
That's not what I'm saying whatsoever. I'm not even saying we. I'm saying what's happening is not it's not some ununderstandable thing. It's understandable from the perspective that they're coming from, which is to be the number one influence, not United States, but this whole entire umbrella. I'm not saying we or it's a good thing or I'm a part of it. I'm just saying that I understand it. And
It sounds
anybody
like
else
you're
who was
minimizing
right
it.
would be doing the same thing.
It sounds
No.
like you're trying to minimize it by saying you understand strategically what they're doing. Why don't you? I don't understand why you're not saying, yes, it's wrong to do these things.
Well, it is
I mean, it's one
absolutely
thing to say
wrong.
it's a strategically smart move. That's fine, because it could be, right?
Let's say
But
that
to say it's
Russia is
natural
really.
is fucked up.
Let's say that Russia really would be a bad influence on the world, that they gained a complete foothold in the world and pushed their ideology. Would that be better than doing it? So is it better for us to do it or for them to do it? If with our influence, hopefully we can get a better outcome. We failed, but the objective may have been more hopeful that they would have ended up with a freer country that was favorable to fostering life and liberty, let's say. And we fucking failed.
That's not even my
That was
point, though.
the-
But I see what Mark's saying. That's not my point. Even it's my point's not that it's a good thing or it's they would be doing it if it wasn't us doing it. That's one of my points, and it's natural, so it's okay. It's not also not my point. What I'm saying is it's a natural inevitability, meaning it'd be happening even if it wasn't our influence doing it. I mean,
Then
there's
how
a
do you
vacuum
explain like the
of
Geneva
world
Convention
power.
and international conventions that have tried to like put a stop to this behavior?
Yeah, the Geneva Convention is like all those things, all those kind of tools are just tools that we use at our advantage. And now when I say we, I mean everyone who works by it. Because when you look at things like the Red Flag event, the Red Line event in Syria in 2013, that was that was basically a product of the Geneva Convention, and it was basically used in order to justify our invasion of Syria, which we were about to do up until Russia calmed that event. But we were gonna go into Syria because of that Red Line event that was basically a infraction of the Geneva Convention.
Are you talking about that sloppy intelligence operation where they acted like the Syrian president bombed his own people with gas? Is that what you're talking about?
Yeah, well, yeah, with chemical weapons, yeah.
Yeah, that was bullshit. You
What
know
about
that, right?
mitigation? What about mitigation? Like we knew we had blown up the country. We had made a power vac. What should we have just left that? Assuming that that's a foregone conclusion. 20 years ago, that happened. Now, should we have gotten out there day two and let the genocides take place? Would that have been better? Is that one likely outcome that would have happened? Maybe it wouldn't have happened, but that's what our thoughts were that was going to happen.
So
And
you know this.
we tried to mitigate that. Is that a legitimate reason to remain and bomb?
You know the richest country in the Middle East, or one of the richest countries in the world, Saudi Arabia, has been engaged in a war against Yemen, arguably one of the poorest countries in the world since 2015 with U.S. support. The UN calls it the worst humanitarian disaster in history.
Yeah.
Okay.
Yemen's bad.
Is it a mitigating? Is there any reason for you to continue bombing if you think that it's going to mitigate a worse event?
That's our peoples. We let people like that run around. Those are our people. The Saudis, we're cool with them. We're tight. We let people like them, Idi Amin, run wild. I mean, we're friends with the worst.
No, I think.
Well, you can't fix a problem with bombs. You can't bring a more humanitarian result around by bombing people. That doesn't work.
For instance, George Bush was president. George Bush Jr. was president, and he was enacting orders that George Bush Sr. wanted to do, and they go into Afghanistan, and George Bush wants to war in Afghanistan for seemingly whatever reason, and then you're the president after him. I think the right thing to do in that situation is to put crimes against anybody who wrongfully went to war in Afghanistan, not purposely perpetuate, a war there just because you already started one. You don't want it to collapse now that you've started a war there. I think now that you've done something wrong there, or somebody else before you did something wrong there, you got to fix what had happened, not by keeping your soldiers there, but by putting the people who did wrong, putting the justice, and then do what you have to do. But that wasn't the goal ever. What the goal ever wasn't to right the wrongs of other people. It was to perpetuate and eventually dominate this place. Like in Libya, they felt success. They were successful after they got Gaddafi out, and they were trying to do the same thing in Syria, and they were trying to do the same thing in Syria and Afghanistan the whole time. They were trying to gain complete control over Afghanistan, put a new leader in place, and sustain a government that was, under this influence, the same way the other Sunni countries were, and all the other people in our umbrella.
But let's be real, with
Libya
Syria, they tried in the beginning, and then Bashar al-Assad basically, acquiesced to whatever demands, it seems like, because after a while, America was fine with keeping it. If they actually wanted him out, he would have been out, just like Gaddafi.
Russia, man.
One thing that I've noticed in the Middle East.
That red line. Go ahead, Mr. Mike.
I was gonna say one thing I've noticed in the Middle East is I watched a TV show and it kind of clued me into some stuff in the Middle East that I'd never really thought about, because I came at it from a more liberal standpoint of let it lie, let them work it out themselves. But in this show, it's called Tyrant. You watch a guy.
I thought what you were talking about.
He had some wonderful ideas. He was a good guy.
It's based after Bashar al-Assad in Syria.
It turns out that you really need like a Saddam Hussein or whatever, in order to remain in power in that part of the world. It seems like you need a strong man. There's weak men are taken advantage of.
That show was completely propaganda, though. It was propaganda against Bashar al-Assad.
But is it true, though? Can you have a weak, liberal, freedom-based government in the Middle East?
I think so. I think you can have not a weak government, but you can have.
It depends on if there's weapons or not.
Yeah, it depends on how you're keeping control. But
well, weapons are always there. There's no way to get rid of weapons.
No, I mean, if they're scattered amongst militia, then it's a problem. If it's like
they use IUDs. Using IUDs would be ineffective. So they use IEDs. You can blow up convoys. These people,
they don't use them against their own people. They use them against the terrorist Americans when they were invaded.
They use it against their own people too, their government.
No, not really.
Now, they may have said that their government was installed, but the people who are taking over, I don't have a real good feeling that they're going to be real freedom-based. Then maybe they will. We'll see.
Libya under Gaddafi was the most prosperous nation in Africa, and now there's slaves traded openly in Tripoli, in the streets of Tripoli.
Oh, they took Gaddafi out.
They weren't the most prosperous nation, but they were. Gaddafi wasn't the bad guy that they were claiming he was. That's true.
No shit. The bad guy was.
Well, he was the thing is.
Let's be real. Gaddafi was a shitty leader.
No, but the one thing he wasn't aligned with anybody at all.
I know. He wasn't aligned with the IMF and the Americans, and that's why he got killed.
I'm saying if you aren't,
he was made to seem like a bad guy for that reason.
If you aren't using their playbook and following their rules, they're gonna fucking take you out. These people don't give a fuck. If they want to control everything.
Exactly.
All I want to know is
perspective.
What happened to the weapons of mass destruction in Iraq? Did we ever find those?
No.
No. That was a ploy to get in there, but it's same thing with Iraq.
Lied to the UN.
Iraq was another example of Libya. Yeah, it's all just a ploy just to consolidate these things that were somewhat powerful, but also not aligned with this influence. Once everyone's aligned under the same influence, the only reason to have a war is to suppress rebellions. But other than that, things are gonna be smooth sailing, and people are gonna get these large powers are gonna get done whatever they want to get done. The whole point of that was just to consolidate power against the opposing power, which would be the Russia and at the time China, but not so much, and suppress those powers so they have no allies. And then the plan was probably to overtake Russia and then end the whole thing and just be dominant. But now it's a whole different game where you have China, which is probably more powerful, or about to be more powerful, and these allied or these rebel powers are not at all, aligned with us at all. They're kind of just docile.
China's about to be a problem big time. We've given them so many fucking dollars over the years for their cheap crap that keeps breaking. I mean, they got to be raking it in over there.
Oh yeah, there's some ridiculous wealth over there for the few people who are involved.
I actually
Don't
heard
mock their stuff, though. Their stuff is not as bad as you think. Their stuff is improving.
I actually heard there's 8 people in the world right now that have more wealth than half of the other world, half of the rest of the world, the other half.
There's no way to know that for sure, but yeah, there's a lot of the wealth is held up by just a few people, sure. But China, I think,
and these
I've
people
said this for a long time. Yeah, and you look at the World War I and World War II, Germany played the same role in both wars. They were the aggressor, and Russia played the same role in both wars. They were the reluctant victors, and we played the same role in both wars, where we were like we came in at the end of the game, and then we also were the victors. But I think in the World War III, though, the big war, the war that I think is already happening, I think that we are going to be seen as the aggressors, and I think China will come in as the late victors. I think Russia will probably play the same role.
And do you think World War III is happening in the mental, or what's going to happen with bombs and tanks on the field?
No, I think that when the history is written, World War III would have started at 9/11 when 9/11 happened. They were probably already described all these.
Will be fought with drones. It's gonna be a real interesting war.
Well, they'll probably describe World War III as all these events happening in this time, and then culminating at some actual, especially this event that's happening right now with COVID. This is probably, I wasn't thinking this before, but this is probably going to be a big part of what's going on, because it seems like there's something going on now that's not going away. Like it seems like there's something happening now that's going to be the way that the world is now.
Kosho, you ruined the last half of the show. You realize that, right? Are we still live?
Yeah, we're still live, but I'm going to close it out right now. Thanks to the panel for being on the show tonight. Really appreciate it. Good discussion. And we'll be back tomorrow night. What else am I supposed to say right now? Oh yeah, I'm going to record after the show. It usually runs all night. So if you're in here, just be aware that you are being recorded. And I usually don't do anything with those recordings, but they might pop up on the internet at some point in the future.
Yo, we've been killing them in here the past like 4 or 5 days. You're just killing them. Come check us out. We're in here 24/7.
Yeah, we got a lot of good people hanging out in the server now. It's really nice to see.
Some
really good modding, and it's going really well. Anybody who didn't get a chance to speak too much during the show, or has something they're burning to say before we leave YouTube, you got a chance now. So go ahead.
Hoorah!
There we go. All right. With that, I'll close it out. Thanks again, guys. All right.
Yeah. Hey, Jeremy.
Kosho.
Oops, forgot to hit that one. Thanks, guys. Appreciate it. Thanks to the mods in chat. Good night, PJ. God bless you too, man. Have a good one. And everybody have a good night. We'll be back tomorrow. We'll do the first half E only. And I'll talk about that perspective stuff that I've been teasing for quite a while. See how that goes. And we'll go from there. All right. Talk to you guys later.